All right, good afternoon, everybody. Ms. Apodaca, could you double check and make sure we have a court reporter?
Yes, is our court reporter back online?
Yes, I am.
Thank you.
All right,
Thank you.
great. Let us know when we're on the record then.
We're on the record as soon as you say so, sir.
Okay, then I say so. Let's go back on the record. Mr. Rankin, are you ready to proceed?
In just a moment, Mr. Hearing Officer, I'm just getting reconnected to the Wi-Fi. One
Oh,
moment.
all right, great. Dr. Lindsay, I'll just remind you, you're under oath. Oh, one other thing. You have a habit of saying, uh-huh. If you could, just for the record, if you can try and remember to say yes or no.
Okay.
I
Okay.
think the court reporter is probably getting it down, but it's less ambiguous. that
Okay.
way. Okay, thank you.
Excuse me, Mr. Rankin,
Yes.
if you could just take a beat before you, and let the witness answer the question.
Yes.
Before you start speaking again, that I'd
Yes.
appreciate. Thank you.
All right, I'm ready. Good afternoon, Dr. Lindsay. I'm going to pick up on a new topic from where we left off before lunch. I'm going to talk with you a little bit more about your opinions about the potential for contamination from the San Andres into the Goat Seep. And I'm going to go back to what? I may need to close out my Adobe. One moment. All right, sorry about that. I'm going to go back to your Exhibit B, which is your February 2024 testimony, and I'm going to go down to the section of your testimony where you address potential contamination into the Goat Seep from the San Andres. Oh, yeah, thank you. Share my screen so you can see what I'm talking about. Let me know when you can see my screen, Dr. Lindsay.
I see it.
Okay. This is under a subheading E, and you say here, it's more likely than not that Goodnight's injection of high salinity water into the San Andres would contaminate the Goat Seep low salinity aquifer attached to the Eunice Monument and Arrowhead Fields due to its greater density and increased pressure as more water is injected. Did I read that correctly?
Yes.
Okay. Now, your opinion that Goodnight's injection is more likely than not going to contaminate the Goat Seep is based on your understanding that the Goat Seep has a total dissolved solid concentration of less than 10,000 milligrams per liter or parts per million, correct?
Yes, and that it's connected to Eunice Monument, pressure-wise. So that means porosity in the Goat Seep and porosity in the Grayberg are connected.
Right. but I guess my point is that, yeah, your statement or your opinion is that the goat seep has less than 10,000 parts per million TDS, right?
That's correct.
Okay. And your statement, opinion that the goat seep has less than 10,000 parts per million, it's based on your personal communications with Mr. Alden Carpenter at Chevron, right?
Yeah, well, just not me, the whole office.
Right.
He came from La Habra, California, where the office was that he worked in, to our office in Midland and presented all the data. And so everybody working on EMSU, MSUB, and AGU were all in attendance, and anybody else that wanted to be there. So it was a fairly large group, just not me.
Just not you. But I guess my point though is that your statement, your testimony today about the water quality in the goat seep is based on that presentation that Mr. Carpenter made
Yes.
to Chevron, and you're
Yes.
in attendance.
Yes.
And you took notes on that presentation, and those notes and your recollection of that meeting and presentation is the basis for your testimony that the goat seep has less than 10,000 parts per million.
That's correct.
Okay. But you haven't yourself conducted an independent investigation of the water quality in the goat seep, correct?
No, that was Alden's job. He was a geochemist.
And you've not reviewed any other geochemistry or chemistry data for the goat seep as part of your analysis or your opinion today, correct? Other than Mr. Carpenter's presentation to you.
There was one other fellow that wrote a PhD on it, and his name was Hiss. And I've listened to some of what he had to say, but that's all.
Okay. Yeah, we're going to talk about Hiss a lot at some point during this hearing, for sure. Okay, so your recollection is that Hiss had some data showing that the goat seep had somewhat lower TDS then, is that right?
Mm-hmm.
Below 10,000 TDS?
Yes.
Okay. So the 2 points are Mr. Carpenter and Hiss.
Yes.
But you haven't presented any data as part of your testimony today on Hiss, have you?
No.
And you haven't cited to that. So this is the first I'm hearing that you're relying on Hiss for that statement.
No. I didn't use any of his data.
Right.
I've just heard what he had to say.
Okay. And just so it's clear for the record, you didn't reference Hiss in any
No.
parts of your testimony.
No.
Right. Okay. So now on this water issue, okay, about goat seep, I'm going to go down to your exhibit B21. Okay. 1 second. And I think this cross-section was shown as part of your summary testimony, correct?
Yes.
Okay. Only it was just the cross-section that was shown and not the caption to the right? As
No,
part
I
of your
think the
summary?
caption was in there too.
Was it? Okay.
Yes, it was in there.
Okay. So this cross-section, this, I guess I'll call it a stylized cross-section of the EMSU, as I understand it from your summary and your written testimony, shows the 3 categories or types of water that were identified by Mr. Carpenter in the EMSU, right?
Yes.
And we have the edge water, which is coming up from down dip from the west, which is the goat seep, and it's symbolized here with a little E, correct?
Yes.
And then we have the bottom water, which you've identified here with a B, which is in the upper San Andres, and that is lower TDS and sulfate rich, right?
Yes.
And I neglected to say that the edge water is also lower TDS and sulfate poor, correct?
Yes.
Okay. And then you got up here with the C is the connate water, right?
Yes.
Okay. And these this representation that you depict here was done as a result of Mr. Carpenter's analysis, right?
That's correct.
Okay. And I want to ask you about the chemistries as we walk through this, and I may come back to this a little bit later. But right now I'm going to ask about the encroachment of the edge water. When we spoke about this exhibit during your deposition, I understand from your testimony to me that Chevron was able to actually measure the encroachment of this edge water up into the structure. You could actually see it in pressure readings, right? And you could see a pressure wave of
Yes.
this water encroaching, right?
Yes.
And you're able to measure that water coming up all the way to the top and across the crestal zone of the double humped anticline, right?
Yes.
And the vertical offset here is something on the order of, about 300 feet, correct?
Yes. Let's see, it'll be, depending on where you start, it gets up to minus 350. And as you go back into the reservoir, it'll be down about minus 600. So that's the interval.
Yeah.
And then it thins out as you go up.
Okay.
To the east. It becomes thinner.
And so based on Carpenter's study, right, he was able to clearly identify, based on the water chemistry, a clear signal of goat seep water coming up, correct?
Yes.
But at the same time, I understand that it was common knowledge that there was all this pluming of San Andres water coming up from fractures through the Crestal High and other locations throughout the San Andres into the Grayburg. How is it possible that Mr. Carpenter was able to obtain a clear signal of sulfate poor water in the Grayburg from goat seep encroachment if, in fact, there was all this water coming up, pluming from the San Andres?
Well, the plumes are just little one well plumes coming up like this, like my finger. So if you get away from those, you can get a good sample of the edge water.
Okay. And if that were the case, if water's coming up from the San Andres continuously prior to even to the water flood being commenced, wouldn't that pluming of water disrupt the pressure front and interrupt the encroachment of goat seep water up dip?
Yes.
Okay. But that's not what Mr. Carpenter saw, was it?
This is where he got his data, and we superimposed it on the structure.
Okay.
Okay.
At the time of your August 2024 testimony, and then again when I deposed you in January of this year, you were not aware that the EMSU had a produced water disposal well that was injecting into the San Andres, correct?
Yes.
Okay. And you'd been working at Chevron since 1988, but you were unaware that Chevron had itself and XTO after and Empire after them operated a saltwater disposal well that was injecting into the San Andres within the EMSU.
No, that was an engineer's job, not
Okay.
mine. Okay.
Yep. And you didn't evaluate that and Empire didn't inform you of that as part of your preparation for the testimony.
That's correct.
Okay. And until your deposition in January 2025, you'd not conducted an independent investigation of the potential impacts of that saltwater disposal well that's in the middle of the EMSU on the EMSU, correct?
No. Yeah. No. I didn't do anything like that.
On
My
the topic,
job is reservoir characterization.
understand.
Okay. Not engineering and disposal of water. Let's get that perfectly clear. Okay.
Yeah. Understood. On the same point, I just to make sure I understand, okay? The EMSU was a water flood, right?
Yes.
And it had 6 water supply wells. Do you understand they had 6 water supply wells that were providing water for water flood operations?
Yes, I knew there was quite a few. Yes.
And you understand that they were within the interior boundaries of the EMSU?
Yes.
And you understand that they were completed and producing water from the San Andres, correct?
Yes.
Okay. But at the time of your testimony that you submitted in August 2024 and your deposition with me in January of this year, you had not evaluated and you were unaware of where those wells were actually completed in the San Andres, correct?
Yes. That wasn't my job.
Okay.
My job was to describe cores and correlate the stratigraphy inside of the Grayburg Reservoir.
Understand.
Okay. Not to know where perforated intervals were in the San Andres. That's an engineer's job.
I guess, though, Dr. Lindsay, as this issue before the commission is a fairly complex issue, and it's not just, it's not just understanding the stratigraphy, but it's also understanding what's in it, right?
Yes.
And you're telling the commission that there's an ROZ down through the San Andres. And I would think part of reservoir characterization would be to understand what the history of the reservoir is or was. Is that a fair assumption?
Yes.
And part of the understanding the history of the reservoirs, understand how it was treated, what was it, were there disposal wells and where they were located, and what the volumes were that were disposed, were there water production wells and where were they located, where were they completed, in what zones, and how much water did they produce? That seems to be part of the question.
That has nothing to do with the reservoir. My focus was on the reservoir and how the plumbing system, how it was connected. Okay, not where water was being disposed of or where water was being taken out of the San Andres for the water flood. That was a reservoir engineer's job. My job was to focus on the architecture of the reservoir. Okay.
And when you're talking about the reservoir, you're talking about the Grayburg?
Grayburg.
Okay. Now, moving on from that topic, let's talk about water chemistry. I'm going to go to your PDF, back to your exhibit B. Well, before I do that, I do have a question, I guess. Go back to that question. Go back to that exhibit. Earlier when we were talking about the boundary between the Grayburg and the San Andres in I think it's your exhibit 1 actually, where you show the many layers or different cycles within the Grayburg. And I think you say here too, that there is a composite sequence boundary between the bottom of the Grayburg and the top of the upper San Andres, right?
Yes.
And that the reason that you're seeing this edgewater encroachment that follows the structure and stays along the base of the Grayburg is because that composite sequence boundary is low porosity, low permeability, right?
It's either that or you have better permeability and porosity in the Grayburg, and the water follows the pathway of least resistance. Okay, so it's probably coming up through porosity in the Grayburg. Okay. And there tends to be maybe a little less porosity towards the base of the Grayburg, maybe at the top of the San Andres. But it's following the pathway of least resistance. And that's going to be through porosity in the Grayburg.
And so in carbonate systems where you have horizontal bedding and plane bedding, you're telling me that water is generally going to follow the horizontal bedding because in this case, it's the path of least resistance.
Yes. And there's more permeability horizontally than there is vertically, unless you run into fractures. And then the fractures will overwhelm the horizontal permeability.
Okay. But here, based on Mr. Carpenter's analysis of the water chemistry and the pressure front that you're seeing, there was no indication of San Andres coming up into the Grayburg.
Not with this data.
Okay.
Yeah. All we wanted to do was show the 3 different water chemistries and where they were located.
Okay.
That's all. Nothing about plumes.
Just on the point about water chemistry, just to be clear, when you prepared this testimony exhibit B in August of 2024, you did not independently review any other chemistry data other than the notes that you took from Mr. Carpenter's presentation, right?
That's correct, though there was one other water chemistry study done by another independent fellow a few years later that got a few samples from Eunice Monument as well. And that was actually published in AAPG in their bulletin.
Do you recall the author of that paper?
I can't recall off the top of my head. I understand he's passed away.
Okay. But was that a paper that you included in your references or cited to in your testimony?
No.
Was it a paper that addressed the Grayburg or did it address the San Andres? What was the
It was looking at the water chemistry in Eunice Monument and anywhere else where he could get some data.
Okay. I want to talk a little bit more about the sulfate enrichment question. Okay. In your direct testimony, and in your summary, and we just talked about it, that one of the key assumptions, as I understand from your testimony, is that the San Andres tends to be sulfate enriched, whereas the goat seep tends to be sulfate poor, correct?
That's correct.
And because of that, if you were to take water samples, as Mr. Carpenter did, he was able to discern, he believes, a difference between the two sources, right?
That's correct.
Okay. Now, but as we discussed earlier today and reviewed in your earlier testimony, and as part of your presentation earlier, we understand that both the San Andres and Grayburg in the EMSU were swept by Mother Nature's water flood, correct?
Yes.
Okay. And in your direct testimony here, I've highlighted a portion of your testimony where you say dissolution of evaporite strata, which is calcium sulfate, right?
Yes.
Added sulfate to low salinity San Andreas water as it recharged into the subsurface. Did I say that correctly?
That's right.
Okay. And then the next bullet, you say through time, recharging meteoric water delivered low salinity water, less than 10,000 parts per million, containing sulfate into the San Andreas residual zone, the ROZ, at EMSU-B, EMSU, and AGU, correct?
That's correct.
Okay. Now, my understanding is that evaporites are anhydrites, or rather, anhydrites are evaporites, correct?
That's correct.
Okay. And anhydrites are in the Grayburg in the EMSU, correct?
No,
No.
they're up dip of the MSU.
So
There's a little bit of anhydrite cement, but there's no bedded anhydrite in EMSU.
what's that based on?
Core studies.
Core studies?
Yeah, the rocks never lie. The rocks never lie. So we look there and we see what's really there. And we look really close and we make a lot of thin sections so we can look inside the pore system in great detail. But we do not see bedded anhydrite inside of the MSU. It is up dip, and that's what makes the stratigraphic trap.
But isn't the EMSU a stratigraphic trap? Oh, I see. You're saying
It
you're
is a
saying to the east.
stratigraphic trap.
It's a
Yes, because
structural
of the
trap.
evaporites.
Got it.
That's what makes the lateral stratigraphic trap.
Understand. So you're saying that there are no anhydrites in the EMSU.
There's no beds of anhydrite in EMSU. There are evaporite cements in EMSU, but there's no bedded anhydrite.
Okay. What kind of evaporites are in the Grayburg?
I thought I just answered that. It's anhydrite.
In the Grayburg?
Yes.
In the
And it's
EMSU?
it's anhydrite cement.
Okay.
Okay.
Are there evaporites in the EMSU in the Grayburg? Or are they all just up
Now,
dip?
now, are you talking about bedded anhydrite? There's none. There's anhydrite cement in EMSU. It's a small percentage, a few percent, but it's there.
Okay.
But it's just cement.
So the distinction
no
you're
beds.
making is that when you say bedded anhydrites, you're talking about thicker deposits of anhydrites.
A bed, a layer,
Okay.
however thick. Okay. There's none in EMSU in the Grayburg
How are anhydrites formed?
by evaporation of seawater.
Okay. But I thought when we went through this before, when we talked about this 88 layer
Yes.
stratigraphic representation of the EMSU, that there were 88 different sequences of seawater, ocean level changes, correct?
That's correct.
And every time we had a sea level change where the sea level receded off that shelf, we had evaporites form, correct?
Not necessarily.
Okay.
Why don't you go to the other illustration that shows the regional cross section and the 3D seismic, and I'll show you right where the evaporites are, the bedded evaporites.
Is this the one?
No, it's the one with the seismic.
This doesn't have the 3D seismic? Because it's not the one you're talking about?
No, it's not this. Go to the one with the seismic.
I'm not sure which exhibit it is, but I'll keep scrolling until hopefully we find it. Is this the one?
There.
Okay.
All the orange on the right, which is up dip to the east, the orange layers are bedded evaporites. The yellow are non-porous sandstone, dolomitic sandstones. And if you look above where it says EMSU and come down, there's where the reservoir is located. So there's no bedded anhydrite in EMSU. There's just cement.
Okay. But there are some anhydrates. There's cemented anhydrates in the EMSU and the Grayberg.
There's no cemented anhydrite. That infers a layer of strata. It's just cement, maybe 5%, and the rest is dolomite.
Okay.
Okay, that's all.
Okay. Now, we discussed the meteoric water swept the Grayberg, correct?
That's correct.
And if I go to exhibit B1, I think you had a nice image of the entire basin subject to the Mother Nature's water flood.
Oh yeah, this is where you're getting it to the west and it's coming down dip and into the basin. And it really doesn't go into the basinal facies. It sweeps around through the shelf margin where all the porosity is located. So if you go to that other map that kind of had a blue color to it, then you'll see the pathways.
Yeah, I understood. So the overview map, which is this one, kind of shows you
This one right here.
Yeah, the direction of flow.
Right there.
But this,
and that's for the San Andres.
okay. Now here, though, in the image at the bottom where you show this is after termination, right, of the flooding process.
Yeah, as you lose your pressure and you
and
destroy the recharge area.
Okay, and in this image, you show that subsequent to the flood, you have hydrogen sulfide moving up and down, moving up from the up dip.
Yeah, it's coming out of the basin. Yes,
It's what?
it's coming up out of the basin, the
Right.
H2S.
So in both the Guadalupean and Leonardian formation intervals, you're showing that there's sulfates in the system from hydrogen sulfide, correct?
Yes.
Okay.
Yeah, H2S.
H2S.
So if you want to go out and see an example of that, just walk through Carlsbad Caverns. That's what made it. The H2S mixing with fresh water made sulfuric acid and dissolved the carbonate and made the big caverns.
And where there's H2S, there's also sulfate in the system, correct?
Yes,
Okay.
H2S, yes.
So doesn't this also show that there would be, or you're expected to see, sulfates in the Grayberg?
Well, that's calcium, anhydrite is calcium sulfate,
Right.
and it's in the Grayberg. It's cement. Okay, so I thought we talked about that.
Yeah, I guess I'm trying to get at the point though that you're distinguishing based on Mr. Carpenter that there is no sulfate in the Grayberg.
This is sulfate cement. And Alden was talking about the water chemistry. That's totally different.
Well, I guess my point is that if there's sulfate in the Grayberg, it would also dissolve in the water, wouldn't it?
It would. Now, you'd have to have an awful lot of anhydrite to dissolve to get enough in solution so Alden's machines can detect it. And apparently he couldn't detect it.
Okay, so even though you had all that anhydrite cement just to the east up dip, there wasn't any.
That's bedded anhydrite up dip. Okay. And in the reservoir, there's maybe like 5% anhydrite cement. It's a very small volume. Matter of fact, it was actually reduced when Mother Nature's water flood came through because it preferentially dissolved the anhydrite first and pushed it out of the reservoir as it was pushing out the oil. So that actually created less anhydrite cement inside of EMSU in the Grayberg Reservoir.
Okay, very good. I'm going to move to Exhibit B23 in your direct testimony. This is again your cross section of the 88 different cycles within the Grayberg. I don't think this is actually what it meant to be. Meant to be on B23. My apologies. Okay, so this exhibit B23, as I understand it, is a composite of two different cores, correct?
That's correct.
And on the left, the upper part of the chord interval is from the EMSU 649 well.
Yes.
And the lower part is from the EMSU 679 well that we discussed before, correct?
Yes.
Okay.
And they're one location apart.
I'm sorry?
They're one location apart. So just a few hundred feet is where the one core, the 649 was taken to the north, and to the south, the 679 was taken.
Got it.
So we could get a bigger, longer section to look at.
So what you've done here is you've blown up a portion of the, really it's the lower portion of that core, the EMSU 679 on the right,
Yeah,
correct?
Just in the San Andres and,
Right.
and just a little bit of the Grayberg.
And you've indicated here your pick for the top of the San Andres, correct?
Yes, and that's based from the core. It's a beautiful subaerial exposure surface.
Okay. And based on your pick of the top of the San Andres, you've identified in the is this the portion that you've identified here as having porous oil stained dolostone and collapse pressure? You've identified areas that have basically oil staining, correct?
That's the black bars are the oil staining, and the red intervals are the collapse breccia in the core description. So you'll see 1, 2, 3, 4, 5, 6, 7 collapse breccias from the top of the San Andres down to the base of the core.
Okay. And the black intervals, the black bars are from the core log description, correct?
That's visible oil saturation to the naked eye.
Okay.
And then there's a little extra oil saturation at the very base that you couldn't quite see with the naked eye, but the ultraviolet photographs showed it.
So from this section here down, and then there's a bit of missing core, correct?
Yes.
So the portion that you're showing with oil shows go down to about, I'm gonna have to zoom in to see this, but this is the section that you've identified as having the oil shows, correct?
Yes.
Okay. And on this exhibit, there are no further oil shows below that depth, correct?
No, there is.
There are.
We saw some with the UV photographs right at the very base of the core.
Okay, but you didn't show that on this exhibit.
I didn't see them, yes, because they were so subtle. And the UV photographs made them stand out like a sore thumb.
Okay, but didn't you went and took those photographs before you prepared this testimony, right?
I think we presented it between the first and second. I think it's whenever the two plates were added to my testimony.
Well, this testimony has those plates at the end, right? 'Cause
Then,
we went
then
through it.
we had done it.
Okay,
So
But
if you go to the plate with the 679, you can see the saturation right at the very base. It's very light, but you can see it right there. In the very last box on the lower right, you see the gold color.
that right there.
There's the giveaway right there. And
Now-
being a good exploration geologist, I had to say, there's got to be more.
Okay.
Deeper in the section.
Now, but you didn't update this exhibit to reflect your understanding that there's more oil at that depth.
Oh, no.
Okay.
No,
Now-
I just left it the way it was. That had been described in, gee whiz, way back in the early 1990s.
Okay. Well, if that's the case, I mean, why wouldn't you show it on your exhibit? If it was described back in the 90s, why wouldn't you put it on your exhibit?
You mean the oil stain at the
Yeah.
very base?
Yeah.
Because we never noticed it until this last year.
Okay.
When we got the core out to photograph it. And there it was staring us in the face. Because normally you just look at the plain light photographs when you're describing the cores. You don't look at the UV photographs. And we didn't have those. So we photographed those just a few months back. I called up Impower and I said, it might be a really good idea to photograph the 679 and the RR Bell, so you can see, everyone can see where the oil saturation really is, not only in the Graybird, but in the upper San Andres. That's the beauty of those two illustrations. There's oil in the upper San Andres. And that's why we took the photographs. So anybody, me, you, the commission, anybody can see it. It stands out like a sore thumb.
And it's recorded on the core log report, correct?
Yes.
Okay. And do you recall what the oil saturations are at that depth in the core log report?
Not off the top of my head.
Okay. We can go back to that in a moment. Let's skip over that for now. Want to discuss with you some parts of your rebuttal testimony. You prepared some rebuttal testimony, and in this particular testimony here, let me go to it here, page 3. Having a PDF problem. One moment. We take a 5-minute break so I get my PDF to work properly. Apologize.
Sure, 5 minutes.
Thank you.
All right. All right, folks. I didn't bring a gavel, but virtual gavel. Let's bring it back to order and get on with it. Do you have much more, Mr. Rankin?
I do.
Pardon?
I'll try to get going faster. That was a little slow right there. I apologize, but I have a lot
All
of
right.
questions still. Thank you. May I resume? or
Hold on.
Double check.
Are we back on the record, Ms. Apodaca? Let's make sure.
I'm here.
All right, let's go back on the record and tell us when, then Mr. Rankin, you take it from there.
We're back on the record.
Thank you very much, Mr. Hearing Officer. Apologize for the break, Dr. Lindsay. I was unable to get my PDF to cooperate with me. I've got on my screen here your Exhibit B, which is your rebuttal testimony. It's page 3 of your rebuttal testimony. Do you recall this statement that I've highlighted here from your rebuttal testimony? Okay.
Yes.
And in it, you're addressing one of Goodnight Midstream's witnesses, Mr. Preston McGuire, his testimony.
Yes.
And you refer back to your PhD dissertation, which you had prepared in 2014, correct?
Yes.
And you cite to your PhD dissertation and you say, quote, there have been places found in the EMSU, EMSUB, and AGU where faults/fractures have allowed upper San Andreas Formation fluids to move up section into Grayburg Formation strata, which form vertically oriented plumes of upper San Andreas Formation water within the Grayburg Formation. And you go on to say that injected water that is not managed by proper water injection monitoring can cause non-uniform sweep in the reservoir and bypass reserves, correct?
Mhm. That's correct.
Okay. Now you're citing to your dissertation, and I have it pulled up here. I'm gonna just scroll down to it. I believe it's on the second page here. And what I've highlighted here in yellow, I believe, is the portion that you put in your rebuttal testimony, correct?
Yes.
But you left off the last portion of that paragraph from your rebuttal testimony, correct?
Yes.
And you say these localities tend to be only associated with one well, indicating that faults fractures are localized in small areas. Agree?
Yes.
And when I asked you about this in your deposition, I asked you to identify any wells, if you could, in the EMSU where this had been documented. Do you recall that?
Yes.
And what you gave me was the EMSU B 887. Do you recall that?
Yes.
Okay, but that's in the unit to the north, correct?
Yes. It's one well into M sub.
Okay, but that's nevertheless, it's several miles away from where Goodnight's disposal operations are, correct?
Yes.
Okay. Now,
But it's laterally equivalent, and the only difference between M sub and EMSU is a line. That's all. It's continuous reservoir across that. There's just a line there separating EMSU from M sub. It's all the same reservoir. So it doesn't matter where we find these plumes. And we happen to have a core there, and it happened to be oriented, and we got a beautiful fracture study, and there was this plume of water right around that one well, and it was highly fractured.
and you included your description of that fracture study in your rebuttal testimony, did you not?
Yes.
And in that fracture study, you would present rose plots showing the orientation of the fractures,
Yes.
but you don't provide any depth, do you?
No.
Okay, thank you. No, and just for the record, I'm referring to what's been marked as Goodnight Midstream Exhibit B25. That was part of Mr. McGuire's direct testimony. Now, earlier, you and I went through and discussed Mr. Love's 1998 SPE paper, and I wanted to just kind of not revisit that paper, but I wanted to address another paper. I can find. This is a 1997 SPE paper by Matthew Miller and some other fellows with Schlumberger. Have you ever seen this paper before, Dr. Lindsay?
No.
Okay. It's a paper that addresses the EMSU and water issues and permeability issues in the EMSU. And I'm going to scroll down to an entry here that addresses, in particular, the EMSU. And it's the section here is titled Field Observations During Bullhead Gallant Injection. And it goes on to say the Eunice Monument South Unit produces primarily from the Grayburg Formation in southeast New Mexico. And the portion I have highlighted here says the Grayburg Formation is broken into 6 zones between 30 and 100 feet thick. My understanding is that each of those zones is about 30 to 100 feet thick. Is that about right?
That's too thick.
Too thick, you think?
Yes, it's much too thick. Yes.
30 feet's too thick or 100?
The 100
feet's too
feet's way too thick.
thick? Okay.
Yeah, that's a misnomer.
So each layer contains horizontal laminations of or stringers of different permeability. Do you agree with that statement?
No, I do not, because they're not laminations. A lamination is a centimeter thick. Okay? We're talking about bedding that's up to massive, up to 4 feet or greater than 4 feet thick in some cases. So he apparently doesn't understand the reservoir very well.
Okay, but nevertheless, he also refers to them as stringers. Is that a fair characterization?
No, these are beds.
Beds. Okay.
They're not stringers.
All right.
A stringer infers that they disappear laterally. Okay. These beds are continuous.
Through the EMSU?
Yeah. Yeah.
Okay.
Yeah.
Now, he goes on to call them stringers. He says the stringers have horizontal permeabilities as high as several darcies. Their vertical permeability is very low. Do you agree with that?
The highest rock I've ever seen in an a dolomitized Uid grainstone is 2.2 darcies. He better be careful saying several darcies. That's incorrect. 2.2 is the highest, and I only saw one. The next highest that I recall seeing was 750 millidarcies. So saying several darcies, that's not quite correct.
Okay. He goes on to say that many wells had a poor water flood production response. Do you agree with that statement?
Absolutely, yes.
And the response, he goes on to say that the response was characterized by water cycling through the high permeability, he calls them stringers, which handicapped the pressure maintenance program and caused high water to oil ratios. Do you agree with that statement?
Yes.
Okay. And then he goes on to say that the operator, being Chevron, is working to minimize the water cycling to achieve several goals, including increasing the reservoir pressure. Do you agree with that statement?
Yes.
Okay. So do you agree with his statement here that the vertical permeabilities are generally low within the EMSU Grayburg?
Yes, when you're looking at matrix permeability, that is correct.
Okay.
But if you're looking at vertical fractures, that is incorrect.
In this paper, which addresses these water issues in the the EMSU and Grayburg, there's no reference again of any San Andreas water pluming up into the Grayburg. Now you haven't seen this paper.
I haven't seen it.
Okay, so you're not familiar with it.
No.
Okay.
Yeah.
Well, Mr. Examiner, Mr. Hearing Officer, Commissioner, I would move this as Goodnight Cross Exhibit number 2.
Any objection from Empire?
Well, I think the witness testified he's not familiar with it. I think Mr. Rankin's used it in cross. I don't know that it should be admitted into evidence as an exhibit.
Well, he's been examined on it, and he's been examined on fine points within the paper, and he's demonstrated knowledge and understanding of the technical points in the paper. So I don't think that we can unring the bell. Objections from Pilot or Rice.
No objection.
No objections from Pilot.
It'll be admitted over Empire's objection.
I might just say that I would be a little worried about what he's saying if he doesn't understand the reservoir. Okay.
Dr. Lindsay, the lead author of that paper was the second author of the paper with Mr. Love in the next year with that we referred to previously. Do you see Mr. Miller is the second author and third author in that
Okay.
paper with Mr. Love?
Yeah, he works for Dowell, so he probably doesn't know much about the reservoir.
Okay.
Yeah, that's a chemical company.
Okay. Now going back to your testimony from your rebuttal. Okay. Let's see if I had this correct. 10 page 4. One moment, I apologize. I may have the wrong. Okay. Yeah, next page down from where you were talking about the your PhD testimony. Actually, before I move off that, I wanted to just touch on a couple of things. You know, I pointed out the one section of your PhD testimony, but in Mr. McGuire's Exhibit B25, throughout your PhD testimony, you had identified throughout that there is a seal that separates the Grayburg from the San Andreas. Do you recall that from your 2014 dissertation?
Yes.
And you go on to say throughout that the reason why the composite sequence boundary is not porous is a not porous pathway from the upper San Andreas formation upsection into the Grayburg formation is explained by subaerial exposure and karstification associated with the upper San Andreas formation was cemented to form a tight non-porous interval of strata. Dolomitic sandstones at the base of the Grayburg formation contain enough dolomitized carbonate matrix that they are also non-porous and non-permeable. Between these two, the non-porous karst and non-porous basal sandstone, a seal or aquiclude, was formed within the top of the upper San Andreas formation and the basal Grayburg formation. Did I say that correctly?
Yes.
Okay.
And I might point out that that seal is not laterally extensive. When you karstify a reservoir, you make sinkholes that tend to be round to oval in shape. And one might be here, one might be over here, one might be somewhere else. And they fill in and they form rather tight rock. They start out as an open porous system, a cavern, and then they fill in with cement and sediment. And we see those in core in the upper San Andreas, but they're not laterally continuous. So you can get a seal, but it's not laterally continuous. And then when the EMSU anticline formed, and you take this flatline strata and you flex it and make the asymmetric anticline, because it's dolomitized, dolomite's a brittle mineral, you fracture it and you break it. So even if you do have something there that is acting like a seal, now it's fractured. And then you get Mother Nature's water flood sweeping through and solution enhancing those vertical fractures and making them wider. And so to have a continuous barrier there, yes, you kind of start out with one, but you don't end up with one.
Now, this was a
and
20.
It doesn't look laterally continuous on logs.
Okay. Now, you didn't say that in your PhD dissertation, did you?
No, I didn't.
And in your PhD dissertation, you said that, and this is the same portion here I'm quoting from, the ultimate test has come from pressure data that shows one pressure system associated with the upper San Andreas formation and a different pressure system associated with the Grayburg formation.
Yes.
Isn't it true that if you're going to have you would need a continuous seal in order to establish different pressure zones or pressure regimes between the different formations?
Yeah.
You would, wouldn't you?
Yes, you would.
And now,
but if it's fractured, you've just lost it. No, they're there. We've measured them. We've shown them to you. They're
I have,
there.
in which exhibit do we have the fractures?
ENSU 679, we have 36 feet of oriented core in the upper San Andreas. I just showed it in my initial deposition. All those fractures are in the upper San Andreas.
Well-
And there's 129 in just 36 feet.
Okay, so I'll get to that in a moment. Now, in your preparation for this testimony, neither your rebuttal nor your direct testimony, did you review any of Goodnight's drilling reports for
No.
its saltwater disposal wells?
No,
Okay. Apologize. I want to pull up your fracture report, Mr. Dr. Lindsay. Thank you. You testified in your direct testimony about your fracture study on the 679 well, correct?
yes,
And that was prepared back in 1991, correct?
that was the first one.
Yeah, and this is the one that you referred to as having identified fractures into the San Andreas, correct?
This was the one where we focused on the Grayberg.
Right. So
Then we
this,
did another one on the San Andreas.
which is the one that you did on the San Andreas?
It's the ones that we showed this morning.
Okay. So the ones that you showed this morning, do you give any depths in that analysis?
It starts at the top of the San Andreas and it goes 36 feet down.
And how do you define and your definition of the San Andreas, correct? How you define the San Andreas? That's the depth you're talking about, correct?
Yeah, yeah,
Okay.
yeah. We found it via core.
But you didn't give us any subsea depths or any measured depths in that analysis, did you?
No,
Okay.
I could give them to you if you'd like them.
Well, I didn't see them in your testimony and I haven't had a chance to evaluate them, but they weren't in your rebuttal, were they?
To the best of my knowledge, no.
Okay. Sorry.
So
This
so
is exhibit
this
B
first report here
of,
was done in Hobbs, New Mexico, just on the lower part of the Grayberg. And then we did another fracture study more recently on the continuation of that oriented core that went down into the top of the San Andreas. So there's actually two fracture studies done on this particular cord well.
um, all right. Two things I want to address from this morning in your overview summary testimony. I'd like to pull up from your direct testimony the exhibit B1. Sorry. Oh, no, it's not. It's this one here. Okay. Want to understand a little more about this. What are the gray zones?
This is exhibit B4. Sorry.
Thank you. I apologize. I need to be better about it. This is
No,
exhibit
B5.
B5 and Mr. Dr. Lindsay's direct testimony. Looking at exhibit B5, Dr. Lindsay, what are the gray zones on this exhibit?
With the question marks?
Yeah.
Those are areas where we didn't have any data, and I did not want to guess what was happening. I only work with real data. Okay, so in the lower part here, the cores didn't go down deep enough, so we knew what kind of rocks were really there and how thick the beds were and how they laterally connected to lateral wells. So we didn't want to put anything in. No guesswork, no guesswork.
Across the Grayberg, then what have you identified? What have you identified as the worst porous quality rock?
The Dolo wax stones.
And where are they on this?
They're the gray over on the far right side.
Uh, is
Where the
this
name is, Dolowax
where I'm
stone.
highlighting right here?
Yes,
Okay.
yes.
So, but that's the
There'll be
worst
gray
quality.
that will be up high, yes, because they're the muddiest rock. They have the lowest reservoir potential.
Okay. It's a little hard to see, but
Yeah, it is.
there are gray intervals embedded in here.
Yeah, there's gray intervals in there. And then there's some blue intervals in there, light blue, that are more mud-dominated dolopax stones. And then the orange intervals are grain-dominated dolopax stones. And the red are dolo grain stones, and they are the best potential reservoir.
The red zones.
The red zones, yes. So best reservoir is red. Next best reservoir is orange. Then the next reservoir, lower quality, will be the blue. And then the gray to the right will be the lowest potential reservoir.
Okay. Just so we talked about this throughout your testimony. I just want to make sure I want to kind of summarize it here. But as I understand, you counted 88 different cycles within the EMSU Grayburg, correct?
Yes,
And each cycle is representative of a change in sea level, correct?
yes,
And with the change in sea level, there may be evaporites forming with each sea level change, correct?
yes. Up dip in the inner ramp
Okay.
where we looked and saw the bedded evaporites. They're just east of the field.
And
They're not right here.
and the two zones that had the worst conformance issues were zone 1 and zone 2, correct?
Yes,
And within the Grayburg, there's a zone 4. Within zone 4, is there a perm barrier that functions as a pressure barrier?
when you go to the east side of the field, all of these dolomitic sandstones that are coming into the field, if I kind of use my hands for if this is up dip and this is down dip, the sandstones that are coming in on the east side, they tend to be tight and non-porous. As you follow them down dip into the reservoir, they become porous. And the reason they're porous is when Mother Nature's water flood swept through, they dissolved out potassium feldspar grains and made secondary porosity in these dolomitic sandstones. There should have been interparticle porosity in these sandstones, but when these sandstones were deposited, they were mixed in with carbonate, and the carbonates filled in all the interparticle porosity. So these things are tight and non-porous to begin with. But when Mother Nature's water flood swept through, the downward, more porous part of the reservoir on the left side of the illustration, when you swept through, you dissolve potassium feldspar grains to make secondary pores. And if you get about 15% porosity with the secondary porosity, you'll get 1 millidarcy of permeability, and that's all. So these sands don't produce very well. And so up dip, where they're first coming in, where the water couldn't get to them that well, they're tight, they're non-porous. As you come down into the reservoir, they become porous by secondary dissolution of feldspar grains, but they're not very permeable.
Very good. I'm going to move on to another topic here. You discussed, and we haven't talked about it yet, the RR Bell number 4. I believe it's in your exhibit B25. Here, again, you've identified what you've identified as the San Andres top, correct? That's your San Andres top.
Yes,
And you discussed the oil saturations that you've identified in the RR Bell number 4, correct?
yes,
Okay. Now, at the time of your direct testimony, you were not aware of what Goodnight Midstream's San Andres tops are.
no,
And you're not aware, and at the time you prepared this, you were not aware of where Goodnight had identified its disposal zone, correct?
that's correct.
Okay. And in the 679,
While this slide's up, could I just point something out to the commission? We talk about all these little cycles. All you have to do is look for the little red surfaces on the top of the blue, and those are exposure surfaces. And the arrows on the left, those little upward arrows, those are individual cycles of deposition, just so you're more clear about what this core description is showing, okay? And that'll be the same way on the other core description as well. Just to point a few things out.
in your opening summary, Dr. Lindsay, you discussed core saturations and a study on the Seminole San Andreas unit that showed using sponge core and pressure core that conventional core has the lowest saturations of core relative to these other coring techniques, correct?
Yes.
And you gave us a range of I think a 14% that you would expect conventional core to be about 14% lower than the other.
18% is where you start.
18% is where you start with what?
Yeah.
So I'm clear.
The oil saturation in conventional cores. That was the number that the Hess engineers talk about.
So they started at 18%, right?
Yeah.
That
And
was
then
that was the oil saturation they recorded in their conventional core.
In the residual oil zone at Seminole San Andreas unit.
Okay.
And so 18%, and then when they would come in sponge core, they would get 24%. And when they came in pressure core, they would get 32%.
What's the increase in saturation from 18% to 32%? Do you know? How much of a change in saturation would that be?
Well, that's 14%.
Between the difference between 18 and 32%?
32.
Okay.
Yeah.
So is there, in your view, based on that study, it's a 14% correction?
Yes.
Okay.
Yes. So that tells you how much super flushing was going on.
So
in the core.
as to the SSAU, given the viscosities, the API, the gravity of that oil, a 14% correction is appropriate for the SSAU.
There, yeah.
But you haven't done an assessment to determine whether that same correction is appropriate for the EMSU.
No, you'd have to compare the oil types, the gravity, the viscosity, features like that to find out how it might compare directly. I have to take my hat off to the Hess people for doing that, because sponge cores are very expensive and pressure cores are outrageously expensive. So I take my hat off to them for being willing to take that kind of data.
I want to talk to you a little bit about how you pick the San Andreas. My understanding from what you've said, and I want to make clear, if I can, is that in order to pick the top of the San Andreas, you need to understand or have the core to do so. Is that correct?
It helps. That's
It
the best. That's his best by far.
Okay. And what is the indication to you in the core that you're at the top of the San Andreas?
You have a very large subaerial exposure surface developed. Not a little dinky exposure surface that would develop on a little cycle within the Grayberg where you might see dissolution down a few inches. You start to see massive dissolution down section in the top of the San Andreas. And that makes it stand out like a sore thumb in core descriptions.
And that same, that's correlatable across the MSU.
Yes, yes.
But you need the core to identify it.
The core helps you the most. And after that, then you tie it into the well log where it fits. And then where you don't have core, you have to correlate the well logs.
And what are you looking for in the well logs to identify that specific?
Oh, you look at the gamma ray, you look at the porosity, you look at the resistivity, you look at all of them tied together. And generally what you'll see in some cases is on that surface, there will be a sandstone called the Premier Sandstone. It's not very thick, but it might be there, and in some cases it's not there. And that helps a bunch too.
Is the top of the San Andreas indicated by an erosional surface?
Yes, it's a big unconformity. There's a lot of missing time there.
Okay. And isn't it true that throughout the lower Grayburg, there are unconformities?
Yes, and they're smaller.
And they're smaller.
They're much
So-
smaller.
So what you're
And
looking
they
for,
don't penetrate as deep and shorter lived. So you can see dinky little subaerial exposure surfaces on most of these cycles. We see little subaerial exposure surfaces. But when you go to the unconformity, like on the San Andreas, you see this much bigger subaerial exposure surface. And if you're really lucky, you start to see the sinkholes and the collapsed breccia and features like that, if you're really lucky. And once you get used to looking at these different levels of exposure surfaces, they're fairly easy to tell smaller surfaces from bigger surfaces. But you need a core to do that. You can't do any of that on well logs.
understood. Now, at the opening of your testimony today, you mentioned that you're not aware, have never experienced a situation where operators of disposal wells were authorized or allowed to inject for disposal purposes into a unitized interval, correct?
That's absolutely correct, because if you're not if you don't have working interest, and if you're not the operator, you should not be allowed to inject inside of a unitized interval. That should be against the law.
So, Dr. Lindsay, are you aware that before the EMSU was even created, there were disposal well operations occurring within what later became the EMSU in the San Andreas?
No.
Okay. So this
Was
well
that-
here.
Was that by some other company other than Gulf or Chevron or XTO?
Yes.
I would wonder how they ever got permission to come in, because once you unitize an interval, you're the unit operator. Nobody else is allowed to come in and work. So how those companies ever got permission, that's a great question, because it sounds like somebody's breaking the law.
I'm going to object to some of this testimony. This is legal opinion. I think this is out of the scope of expertise.
All right. I think the objection's well taken. I mean, it's one thing to say that it should technically not be allowed. It's another thing to say it's breaking the law or it's against.
Oh, that's true.
Okay.
Maybe I should apologize for
No,
that.
you don't have to apologize, but objection's well taken. Try and limit your testimony to technical stuff and leave the law to the lawyers.
Okay, okay.
Thanks.
Of course, now, I've worked on unitization projects, and you try to unitize to the base of your oil saturation. And the base of the oil saturation has to be somewhere down in the San Andreas. Okay, is that a fair enough statement?
Dr. Lindsay, have you reviewed the unitization information that was presented to the commission in 1984?
No.
Are you aware that the information presented to the commission in 1984 represented that the base of the oil saturation was at minus 325 sub C?
That is incorrect.
That's the information that was presented to the commission.
They said that's the oil water contact, but
that's
there's
the,
oil saturation beneath that.
Okay.
All you have to do is look at a core. We just looked at the San Andreas cores. There's saturation there. We became aware of it when we looked out on the west side of EMSU at the EMSU 329. And that original number, minus 325, is completely incorrect. It's actually minus 350 is where, above there is where you tended to get water-free oil production through time. And then from minus 350 to minus 540 is where you started to get a mixture of oil and water. And below minus 540 is where you got water production only. So we had this well, EMSU 329, out on the west side of the field. And when we got down to minus 540, we found the core kept going down deeper and it had oil saturation through it. So we realized right then and right there that we were dealing with some kind of residual oil zone in the Grayberg. And we didn't know where the base of the oil column is. So you call that spot, the minus 540, the producible oil water contact. That's not the true oil water contact. It is much deeper, and we don't know how deep it is.
Okay. I understand that's your opinion, Dr. Lindsay, but
No,
I guess
that's the
I was
facts.
bringing
That's the facts. That's the cold hard facts, my friend.
this exhibit B29, B47 is Mr. McGuire's rebuttal exhibit number B47. And I just want to point out to you that there is a well here. It shows the data first injection for this well, and I'll increase the size for you, but it's 1966, and it's a rice operated well, and it was pre-existing the formation of the EMSU.
Okay.
But you were unaware of that,
I
correct?
am not aware of that.
Okay. Mr. Hearing Officer, may I just take 5 minutes to determine whether I have any more questions? I apologize for the break. I know everyone wants to move on, but I just want to make sure I can confer with my client and make sure I've addressed everything I need to address.
How about I give you till 2:40 PM, which is 4 minutes,
Great.
and you have to bring us back on the record.
Thank you.
All right.
Just gotta hang on to this. I will stretch.
Ready?
I'm ready.
All right. Ms.
Back on the
Apodaca.
record.
Okay, you're anticipating my next question. All right, Mr. Rankin, are you done?
Thank you, Mr. Examiner. I am done. I have no further questions of the witness and pass them for examination by the commissioners.
Okay, well, first I need that.
Might I intervene? I would like my opportunity if the commission.
Well, sure. Let's give OCD an opportunity and then Rice and Pilot, if you guys have questions. I'd like to break at 3:00 for a mid-afternoon break. So, not to constrain you, Mr. Moander, if you're not done by then, we'll just pick up afterwards, but we'll break for 15 minutes at 3:00 or thereabouts.
Understood, Mr. Hearing Officer. Happy to comply. May I proceed? Good afternoon, Dr. Lindsay. Scoot
Afternoon.
over a little so I can actually see you
Okay.
there, around Mr. Padilla's head.
Mr. Moander, let's bring the microphone closer to you.
Can do.
The doctor has a hard time hearing when the microphone's away.
All right.
Thank you.
So, Dr. Lindsay, you're under oath today, is that right?
That's correct.
And you're here to tell the truth?
Yes.
In your earlier summary, you didn't give the full body of your opinions. Isn't that right?
That's true.
And one of those opinions that you omitted was, and I'm going to quote you here, and we'll discuss that in a moment. There's no migration of injection fluids from the San Andres and the Hobbs Channel into the Capitan Reef, right?
The Hobbs Channel into the Capitan Reef. Yes, that's correct.
And you gave that testimony in your initial witness disclosure, right?
Yes.
You also gave it in your rebuttal testimony, right?
Yes.
And you also testified to that you testified to as much in your deposition.
Yes.
And going back to your deposition, do you recall being asked what your basis for that opinion was?
Well, first of all, the Capitan is.
Hold on, doctor. I asked if you remember being asked that question.
Repeat the question then.
The question was, what do you base that on, Dr. Lindsay? And that was your opinion.
Okay, my opinion.
Yes.
As to why there's no communication from the Hobbs Channel to the Capitan Reef. Okay.
Yes, in the deposition.
Yeah. Well, I don't know the exact words I'd use, but I would just simply say it's too far away. Yeah, there's no lateral communication between the Grayburg at EMSU and the Capitan. It's 2 townships away, if I remember right. But there is communication with the Goat Sea Reef.
And did you share all of that with me when I asked you for the basis of your opinion in your deposition?
Yes.
Are you sure of that?
Yeah, I think I did. I told you there was no communication.
You did. I'm going to share an exhibit here. So, doctor, I'm going to zoom in a little. See the highlighted section there?
I don't see anything.
Oh, are we not getting, is the sharing not coming up? Well, that's no fun. Let me try again. Nothing like a good old fashioned technological issue. There we go. You see that there highlighted, Dr. Lindsay?
Okay, yes,
So you do see it.
yes.
And if you look below in line 9 through 10, I asked what you based your opinion on,
Yeah.
and you represented go down to figure B3.
Okay,
So let's take a look at that. I'm going to represent to you
okay, here we go.
that this is the exhibit you based your opinion on per your testimony, correct?
Yes.
All right. So, Dr. Lindsay, do you recall being asked by me whether or not you factored in during your deposition the Safe Drinking Water Act?
Oh, I did not.
No, do you recall me asking about that?
Not off the top of my head.
Would you like proof that that was asked of you?
No, I'll believe you.
Okay.
Okay.
You did in fact say that you hadn't factored it in, but, and I'm going to quote you here. No, but that's an issue because the goat seep is a source of fresh water. Well, low salinity, less than 100,000 or 10,000 ppm water.
Yes, that's the goat seep.
Okay. And then I asked a second question. You said just a second ago that the Safe Drinking Water Act is an issue here vis-a-vis the goat seep. Why is that the case? Answer, I have not reviewed that safe water thing, but just realized when we were studying this that the down dip is the source of fresh water and could potentially be contaminated. Does that sound right?
Yes, and I'm talking about the goat seep, not the Capitan.
So is it your testimony here today that you did incorporate safe drinking water analysis for the San Andres?
No.
Okay.
No.
And did you address the Safe Drinking Water Act in your rebuttal filing before this commission?
No.
So let's shift topics a little bit. My understanding is your area of focus primarily, not exclusively, is the issue of fractures in this case. Is that a fair statement?
Well, it's reservoir characterization, and fractures happens to be part of that.
So fractures are part of your analysis,
Yeah.
correct?
Yes.
And you testified earlier today, as well as providing through your rebuttal, that there are fractures in play in this case as an
Yes.
issue.
Yes.
Okay. One moment. My apologies to the commission. There's lots of paper. All right, Doctor, I'm showing you what's been marked as Empire's Exhibit J4.
Yes.
See, you recognize that document?
Yes.
On the left-hand side, it appears to say San Andres total fractures 129. Is
Yes.
that correct?
Yes.
And is that 129 or that 129 reflects the number of fractures you found in this analysis, right?
Yes, and 36 feet.
36 feet.
Okay.
Let's scroll down to Empire Exhibit J5. Oops, wrong button. Now this Exhibit J5, again, you recognize this document?
Yes.
And again, on the left-hand side, it says San Andres large fractures 18. Is that right?
Yes.
And that would be 18 fractures within how many feet?
In a 36-foot interval, and they're somewhere between 1 and 3 feet in length.
Let's take a look at Empire Exhibit J6. Again, I'll direct your attention to the left side, San Andres small fractures 109.
Yes.
And that was done based on the same parameters that you described with the last two exhibits, correct?
Yes.
And then finally, we'll come to Exhibit J7, Empire Exhibit J7. Again, I'm assuming you recognize this document?
Yes.
And again, on the left-hand side, it says San Andres collapse, breccia, if I'm pronouncing it right, fractures,
Yes.
82.
Yes.
So between exhibits J4 and J7, you've outlined what, over 200 fractures in the San Andres?
Mm-hmm. Yes, and some of them are in collapse breccias, and some of them are small. So we're kind of repeating just a little bit because there's only 129 total.
Oh, so those are duplicative. Is that your testimony today?
Pardon?
So those are duplicative exhibits? Is that your testimony
I
today?
object to the form. I think that misstates his testimony.
I'm just asking a clarification question. I don't understand the basis of the objection.
Rephrase the question. The question is somewhat unfair.
So Dr. Lindsay, those 129 fractures, those account for in exhibit J4, those account for the exhibits in J5, 6, and 7?
Yes. Yes.
So that's
Yes,
100.
because there might be small fractures, and some of those small fractures might be in collapse breccias.
But the point being that there's 129.
There's
total.
129 total.
Thank you. I'll pass the witness.
Mr. Hearing Officer, turn on your microphone, please.
We still have 10 minutes. Let's see, Mr. Beck, You look like you're itching for cross-examination. Do you have any questions?
No, I don't. Thank you.
Okay, then we'll pass it on to pilot. Is it Mr. Suazo? He's maybe asleep. Is there anyone present in the room?
Mr. Hearing, pardon, Mr. Hearing Examiner. This is James Parrott with Beatty and Wozniak representing Pilot. I was having a little trouble getting my microphone turned on. I'll be taking over the remainder of the day from Mr. Suazo, and Pilot does not have any questions. Thank you.
Okay, thank you. Then, I guess last but certainly not least, how about the commission? Would you prefer to break and then do commission questions, or you want to just start now?
I would say let's take a break. I think it's a good natural breaking point, and then we can start up again with the commission questions.
Okay, how about 3:05 PM? It's 14 minutes, not quite 15, but better than 10. Okay, off the record. Sorry, I get easily distracted by things like ChatGPT. I was looking at the great unconformity in the Grand Canyon, which is measured at more than 1 billion years of unaccounted for time. Gives you a new perspective on time altogether. All right. Let's see. Madam Court Reporter, you can guess my next question.
We are on the record.
All right, then, I guess it's time for commission questions. Mr. Rosatos, is there any particular order you guys prefer to go in?
We don't. I'll just say that I don't have any questions. So.
Okay, that leaves you, Mr. Lamkin and Dr. Ampoma. Between the two of you, who wants to volunteer to go first?
I'll go first. Thank you. Okay. Dr. Lindsay, good afternoon to you. Thanks so much for your expert testimony. I'm going to ask a couple of questions, and if you feel like this one has to be a reservoir engineering question and you might not be able to respond to it, please do so. So you've categorized your testimony into different sessions. So I'll start with the A, and the heading, the proposed SWD wells would inject into the San Andreas Formation, which contains a residual oil zone. So I'm going to focus on that subheading. So from your direct testimony on number 6, you talked about, while describing core and characterizing Greenberg and San Andreas reservoirs in the EMSU, located on that area, you just said that it was discovered that the San Andreas contains ROZ. When was this discovered?
Let's see, the first time I noticed this, it had to be back in the 1990s. The EMSU 679 was cored in 1990. And when it came in, I was asked to describe it. And so as we went down looking and getting sampling and looking at the core and finding the San Andreas contact, we realized there was all of this oil stain into the San Andreas. And that was the first time I got to physically see oil saturation in the San Andreas. So that was the first time. And then I was asked to do the RR Bell number 4. And here was another core that not only went through the Grayberg, but went down into the San Andreas. And there was more oil saturation in the San Andreas. So at that point, we realized, yes, there's some kind of reservoir in the San Andreas. And then when you look at the oil saturations, they're really low. And so what we called them back then was a residual oil interval. That's how I termed it. Some people like to call them transition zones. And so I just called it a residual oil interval. But then later terminology came along from Steve Meltzer and another friend of mine, Bob Trenum, where they started to call them residual oil zones.
So which year was it called residual oil zones?
That I don't know when that first came out. Steve could tell you. I'm not sure, because I think when that happened is when I was working in the Middle East, and I don't know exactly when that change occurred, but Steve could tell you about that.
Okay. So in the EMSU, you're saying that it was way back in the 90s, 1990, that was when the first more or less studies was done to identify these type of saturations in the San Andreas.
Yeah, we'd never seen the San Andreas before in EMSU. Well, there was one core that just got a couple of feet into the San Andreas, the EMSU 458, but it was just a couple of feet. That was all. So we didn't get to see much. But in the 679, by coring the EMSU 649 and then coring a little bit deeper in the EMSU 679, which was just one location to the south of the 649, they got this big long core through all of the Grayberg. So we got to see all of that. But then it happened to go down into the San Andreas as well. And that happened to be an oriented core at the top, and it stayed oriented for the first 36 feet into the San Andreas. And then the lower part of the chord interval, they didn't orient it. For whatever reasons, I don't know. So we had that data, and then when we started describing the core, you always start at the bottom and work your way up. So right off the get-go, we saw oil saturation in the San Andreas. And so we said, oh, there must be something here. And at the same time, there were geologists that were working EMSU that said, well, here's our potential oil-water contact, somewhere around minus 714 or minus 750, somewhere around there. So they, and that oil-water contact would, I don't know how they exactly come up with that, but they did. So I saw this saturation in both the 679 and in the RR Bell number 4. And right then we realized there was some kind of saturation in there that was low, but there was oil saturation. And the great catch was, how deep did it go? And we didn't have any deeper cores than those two. So I didn't personally know how deep it went after that, but there was some kind of residual oil zone there.
So from the 90s up until now, has there been any pilot project on recovering from ROZs in the EMSU that you are aware of?
No. Just a lot of talk that there's some kind of ROZ there.
Okay. So on that same number 6, you go further to talk about potentially deeper and is ROZ. Now, so I want to ask you, is it still at prospecting stage, or is it proven, or is it probable reserves that we're talking about here?
Well, what happened was at the base of both cores, we saw oil saturation. And then, like I said before, being a good exploration geologist, you say, oh, if it's at the base of the core, there must be more. How much more is there? But there was no more core. And so that's where my work ended. And then other folks could look at well logs and try to calculate oil and water saturations to see how much deeper that might extend down into the San Andreas. So that's where I kind of had to stop, because then I had to go on and describe the next core, the next core, the next core, the next core, the next core in EMSU and in MSUB and then in AGU. And that chews up a lot of time. So we knew there was some kind of residual oil zone there, but we just didn't know how thick it was.
Has there been any production, either water, oil, that you know of in the San Andreas Formation?
Oh, there's plenty of water production, but there's very little to no oil saturation being produced out of vertical wells. Because we're probably below what we call this producible oil water contact, where we're just looking at residual. And in vertical wells, you can't produce residual very well. By primary recovery, you just can't.
So in your testimony, you talked about ROZs could be from, let's say, 20% to about 40% saturation oil. Is that correct?
Yeah, in some range like that, yeah.
Okay.
Yeah, 20 seems to be kind of a good number to start at. Then you just hope it gets higher.
So what is a typical, I know you have a lot of experience in the Permian Basin. So what is a typical residual oil saturation to water injection in a typical reservoir, let's say Greenberg, for example, or let's say even the Sound Andres that you might have a fair idea about?
Boy, that's a tough question because you're getting into log analysis. And if you don't have a core, you don't know how much oil saturation is really there. And that's all. I don't think I can answer that question, to tell you the truth.
Okay, I will rephrase it another way. In a typical reservoir, let's say I will just use a sandstone for instance. A typical residual oil saturation to water injection, probably about 25%, 26%, 27%, depending on the area that you are working in.
Yeah.
So I'm asking, in the Permian Basin, in some of the rocks that we are talking about here, what would be the typical residual oil saturation to water injection? For instance, at what saturation level would you start CO2 injection in the Greenberg formation?
Oh boy. I don't think I'm qualified to answer that question. I worked with one fellow that tried to answer that question in Goldsmith Field. What's the residual oil saturation there? And this was years ago. This was back in the 1990s. A guy named Doug Jasek, he was trying to figure that out. And it ended up being his master's thesis at Texas A&M. But I can't remember what kind of number he came up with. But he was looking at I believe it was the San Andres. Yeah. When we were working on that particular reservoir. But I don't think I'm qualified to kind of answer that question, because we're getting into kind of the world of more of reservoir engineering, more than geology there.
Now, this one is all on the core analysis, because if you analyze the core, unless probably you say that probably that is special core analysis.
Yeah.
And you do a lot of routine core analysis.
Yes.
Okay, then I got you. I'll save my question.
Okay.
Okay, thank you. Okay. Now, still, I believe on the under number 6, on the Capitan Reef aquifer question. So I want to know, is the gold seep, is it in any way communicating with the Capitan Reef in a way, anyhow?
No. If you go out to the Guadalupe Mountains, you'll see the Capitan. Well, I'll kind of do this. Here's the top of the Grayberg, and then the front of it's eroded away, like so. And then the Capitan glues itself onto it like that, okay? And then the overlying strata progrades much further out. And then here's the Capitan starting to prograde out into the basin. And that distance is several miles. And the progradation of just the Capitan in the Guadalupe Mountains is 8 to 10 miles of progradation, but it does not touch any of the goat seep strata at all. It's further outboard, down dip, and then it progrades about 8 or 10 miles. If you go up to the northern end of the Delaware Basin, there the Capitan progrades about 18 miles, quite a ways. If you swing around to the west side of the Central Basin Platform, there it only progrades maybe 3 or 4 miles, not very far at all, just a short distance. And that's just down dip from EMSU and MSUB and AGU. But the distance from the edge of from this field to where the Capitan is, where it's been mapped, the down dip limit of it is about 2 townships apart. So they're probably not connected at all. But what is connected is the Goat Seep, because you can see it in outcrop in the Guadalupe Mountains. Mm-hmm. And people have from the University of Wisconsin have actually described it and studied it back in the 1970s. And then it comes around, this eroded edge comes all the way around the Delaware Basin. And in front of EMSU, it is eroded away there, and there's the Goat Seep like that. And that distance to this spot to where the field is just a couple of miles. And there, the Goat Seep is in pressure communication with the Grayburg. And that's how the edge water coming from the Goat Seep that is being reached from the Guadalupe Mountains and the Glass Mountains, it's being recharged into the subsurface, and then that water is being sucked by production up dip into EMSU because there's this pressure drop. And this is higher pressure down here. So it's just simply being sucked up dip into the reservoir. And that's how you get the edge water.
That is very interesting. So is the Goat Seep, can it be classified as USDW?
As what?
Underground source of drinking water?
It's less than 10,000 ppm. So it's fairly fresh water. I don't know if I'd want to drink something with 10,000 ppm, but maybe somebody's cattle would.
Okay. But there's no injection that do have a direct communication with the Goat Seep that you are aware of.
Oh, no, the Goat Seep is in communication with EMSU. That's how all the edge water's coming into the reservoir sideways. So if here's the reservoir, here's the edge water coming in like this. It's coming from the Goat Seep through the down dip part of the Grayburg and coming in to the west side of the field. So it's in communication, but to the best of my knowledge, we're not in communication with the Capitan at all.
Okay. And the Capitan is the one that NMOCD is more concerned about.
Yes. Okay. Yes.
On your exhibit B1, what type of ROZ are we dealing with in this area, if you can respond to that?
Well, there's a couple of different kinds of ROZs. There's one that's called a brownfield, and then there's one that's called a greenfield. And the way you define a brownfield is you have a producing reservoir above an ROZ. Okay. So just in real simple terms, you can say, well, here's the reservoir in the Grayburg, and here's the ROZ beneath in the San Andres. So you could say that's a brownfield.
Okay. On your exhibit B2, where you show, and I don't know if you can bring it up, but that is the porosity fairways, faults, and fractures. And based on the cross-examination from Mr. Rankin, I got to know the location of the EMSU. In relation to
we didn't show it, did we?
Yeah, you did.
Yeah.
It was shown here.
No, but where he pointed to it was the right location, though.
Yeah. Okay. So how is the performance of the ROZ in the Talcotton, Goldsmith, and I don't know if it is, it's in Seminole. Can you speak to that?
Boy, I don't have enough hands-on experience with Seminole or with Goldsmith to answer that. When I worked on Goldsmith, what I can tell you is we had all these cores in the San Andres, And one of them went down
Thank you.
into the ROZ. And we knew it was there. We had cored it, and we had the oil saturations, and we could see this profile of higher oil saturation coming down to lower oil saturation. And that interval was probably 100, maybe a little more than 100, well, maybe just about 100 foot of section. And you see it start in higher oil saturations and drop down literally almost to zero at the bottom. Because at the bottom of the core, it turned out it wasn't dolomitized anymore. It was limestone. And the limestone was non-porous, so there was really no oil saturation in that. So we had this really nice ROZ sitting there. And then above it was the San Andres main pay reservoir. And so it was another brownfield, but it was totally within the San Andres. And then to the west side, we were going to try to put in a CO2 pilot in the main reservoir. And when they put it in, it didn't work well. And at first they thought it worked great because there was no early CO2 breakthrough. But after a year or so, everyone said, where'd the CO2 go? Why don't we see a bank forming? What happened? Well, it turned out there was a wettability issue in that reservoir. And if you tend to be more oil wet, there's two ways that a water flood would work. It'll either go through the large pores or through the small pores. And if it's more oil wet, you'll flood through the larger pores. And that's kind of where we were at. Well, the peripheral water flood had flooded a lot of that movable hydrocarbon out. And when the CO2 came in, it popped into these big little micromoldic pores. They weren't exactly small bugs, but they were kind of, maybe fingernail size and smaller, about this size and smaller. And when the CO2 popped in, it couldn't get back out of that big moldic pore. And so what we were doing, we didn't realize, was we were sequestering the CO2 in the reservoir, and there was no oil there in the pores for it to dissolve into. So it was a failed CO2 flood. But what people found out years later was after it was sold from Chevron to XTO, that area around there where the CO2 was injected in, the wells around there started to produce better. So there was this long-term soaking effect of the CO2 that mobilized some of the oil in that area, but it didn't really bank oil because we were basically sequestering the oil for sequestering the CO2 in these large moldic pores. And we did this really detailed study of how big are the pores, how big are the pore throats, what's the ratio? And the answer was, if these are 3,000, this was 1. And so once it popped in, it couldn't get out. So once that didn't work, they never attacked the ROZ in the Chevron acreage. But across the street and to the north in Goldsmith, there was an active CO2 project in the ROZ, from what I understand. But I know nothing about it. But my colleague, a friend of mine, Bob Trenum, he actually got to work on that, and he could tell you about how that worked.
Okay. Just to clarify, did I hear you saying that there is not enough data to make, let's say, to assess the economics of the ROZ within the EMSU? Did I hear you say that?
Oh, for the San Andres, for the ROZ?
Yes.
There's just that little bit of data in the upper part where we've got core analysis. We got the logs, and then we got logs deeper in the section, but we don't know the oil saturations. That's the problem. So we need to get a core down through the deeper part of the section so we know what the oil saturations look like and how big, how in depth the ROZ might be. And that's a real problem.
That is interesting. So if we do not know, well, let me put it this way, then wouldn't it be appropriate for, let's say, your client to drill to get this information? The decision that you're asking the commission to make is really difficult one, really complex, where you have saltwater injection going on, a lot of facilities being drilled, they're built out.
Yeah.
And you're asking us to revoke these existing injection permits.
Yeah.
And even the new ones, we should deny them. I mean, do you believe that enough work has been done in the EMSU to confirm that there is a recoverable oil saturation enough, to warrant these revokes that is being asked here?
Well, we don't have enough direct evidence via core. We've just got indirect evidence via well logs. Okay, about how much oil saturation might be there. But I believe some other folks are going to address that particular issue to help you out, to make a reasonable judgment.
I appreciate that.
In this particular case, yeah.
So in your geological characterization work, you testified that you analyzed 2 wells. Is that correct?
Yeah, in the San Andres, yeah.
Yeah, in the San Andres.
2 cores,
yeah, 2 cores.
There were
Wells
just
with
those
cores.
2. That's all we had. Just a little bit of data. But the really surprising thing was you get to the bottom, there's oil saturation, and you say, "Ooh, how much deeper does it go?" And that's the great question. That's the great question. How big is this ROZ? How much oil is there in place to try to be recovered by whatever process?
So what is the distance between the 679, or is it, the 2 wells?
Oh, they're about, there's a map. There
is a
my
map.
very
If you
first-
can bring it up for me.
I think my first illustration, if we could bring that up, I could show you the distance, because we've got them on there. Is that possible to bring that up some way, somehow?
I've got it. Is it in your direct testimony?
Yes, it's going to be I think the first slide after the introduction. It's the very first one.
Okay.
It was B4, Ms. Hardy.
B4.
Yes.
Yeah, so there it is.
Right
Okay.
there.
So you can see right in the middle of the field, you can see where the 649 and the 679 is, right next to each other, right there. So there's the 679 went down into the San Andres. And then the RR Bell is way over here to the east. It is up near the stratigraphic trap. So we're kind of really losing a lot of reservoir quality right there. But those are the 2 that got into the San Andres a fair distance. Now, the 458, there at the end, they're on the east side, it got down into it just a couple of feet. That's about all. So the 2 biggies are the 679 and the RR Bell number 4. And that distance is about 2.5 miles apart.
Okay. Now I will get to the
It's
679.
more like 3 miles, excuse me.
3 miles?
Yeah, 3
Okay.
miles. Yeah.
Okay. I will get to that in a second. Now, still under 6, you showed a table comparing Goodnight injection, saltwater injection, water analysis compared to Empire's produced water analysis. So where is Empire's produced water coming from?
Oh, I don't think I showed that. Did I?
Okay, there's
I
a
don't think
table
I-
on page 5 of your direct testimony.
Yeah, let's look at it and see
Okay.
what it was here.
Right there.
Oh, okay. Yeah, this was added in later and that, so I can't say too much about that. Sorry about that. Yeah.
But, so is it not part of your testimony?
This was added in later, okay? By one of the Empire folks.
Okay.
Okay, that's not my data. But it's just showing the range of stuff, because these are the ions you really have to worry about if you're injecting in all of this high salinity water into the San Andres, because it could fix with the sulfate that's in there and create an enormous amount of scale and start to cement up the reservoir. That's the big worry. That's the big worry. You're going to start to destroy the ROZ, basically.
Yeah, but where is the source of Empire's produced water? Is it?
Oh, this data?
Yeah.
I have no earthly idea. I'm sorry. They can respond to that. Okay.
Okay. Okay.
But that's a good question, though.
And since you said you don't know what, because I'm asking, my follow-up was, is this within the EMSU?
That I don't know. I'm
Okay.
sorry. I don't know.
Okay.
I would assume it is, but I don't know.
Okay. Now, if we can go back to the map where we showed the 679 well,
Okay.
so I'm not sure if you can respond, but do you know where at least one of the wells from Goodnight is located?
Oh, I have a base map of where they are, but I didn't bring it with me. But they're basically to the south. It's where most of them are, the southern part of EMSU. I've got a base map, but I left it home. Sorry about that.
So it's way south of the 679?
Where this line is of all these cord wells, a lot of them are just to the south of there. But I don't have a map to show where they're located. I had a hard copy and I left it home.
So, B of your direct testimony, so you've categorized them. Under the B, you talk about geologic and engineering interpretation will identify vertical fractures and plumes which would not prevent vertical migration of fluids. Is it probably am I reading it wrongly?
Let's see.
Which would not prevent vertical migration of fluids.
Let's see, where's this
I don't
at?
remember
Let's see.
what page are you on?
Yeah, so I'm just on page 4,
It's
Yeah, right there.
subheading B, Ms. Hardy.
right there. Geologic and engineering interpretations will identify vertical fractures and plumes, which would not prevent vertical migration of fluids. So meaning there will be vertical migration of fluids.
Oh,
Okay.
because we've known about these plumes for years when I was working in the Hobbs office back in 1988 through 1990, before we moved to Midland and continued work in there. They were well known about. And so the big issue was the fractures. And so we started taking all of these oriented cores so we could do fracture studies. And this was in the 1990s. And then the idea was to try to understand the fracture distribution within these reservoirs and see if they were going to be our friends or if they were going to be our enemies. And then this one core, the 679, it was oriented and went down into the San Andres, so we could see fractures from the San Andres all the way up into the Grayburg. And initially, our work was so focused on just the Grayberg that we only described those fractures in the Grayberg for our initial report. But then later, with all of this hearing coming up, these become really important. So I went back to my original fracture study. I happen to have a copy because Chevron released all my data to me for my PhD. So I was lucky. And because this work was done back in the early 90s. So I went back just last year and did the fracture study on the San Andres part of that oriented core. And luckily I had a hard copy of the data, and so I could put together the different diagrams showing the fracture orientations. That became really important, not only in the EMSU, but up in M-sub, we had an oriented core up there. And then down in AGU, instead of taking one oriented core, we took two, because that was such valuable data to understand these fractures. And in AGU, we actually mapped the area where we started to see bottom water out of the San Andres coming up into the Grayberg. Before that, we just kind of took it for granted that we had these little plumes here and there, these little one well plumes, kind of like my finger coming up like this through where there was a little more intense fracturing. And we just took them for granted. Then after a while, I said, well, it'd be a good idea to maybe map these out. So by the time we got to unitizing AGU in 1992, actually made a map showing where these plumes were kind of located in AGU. So the folks could know that there might be bottom water problems coming up into the Grayberg that would affect the water flood.
So based on what you described, I just want to let's be clear, is the EMSU 679 do have the plume that you are describing?
Right there, we didn't know of a plume, but to the north, which is one well out of EMSU into M-sub, we knew there was a plume there in the 887, and out of dumb luck, that happened to be the well that was cored with an oriented core, and we got a fracture study. So here we knew we had a plume around this well, and we happened to core it, and we took an oriented core, and we got a fracture study. And I remember when I opened that core up to start describing it, there were all these fractures, and I thought, oh boy, this is a real mess. But we went ahead and did the fracture study, and then I described the core. So that's the best one that I can point out off the top of my head. And this is way back in the early 1990s when we were doing some of this work.
So where I'm getting at is you let's say you described one core from 679, but you are using that to generalize, maybe I'm saying that wrongly, that there could be, or there will be, a vertical migration of water that is injected into the San Andres all the way to, let's say, the Greenberg. Is that your testimony?
Yes, there's a problem. And the higher the pressure you generate in the San Andres, the more fluid will move up.
So is there going to be a reservoir engineer to testify to confirm this aside just one core?
That I don't know. That I don't know. Sorry about that.
Well, so is it your testimony that based on one particular well, core information, one well, 679 well, there is this 36 feet, as you described, that is a fracture right there.
Yeah.
So that is why I wanted to know the location of the Goodnight saltwater injection well in relation to this particular 679 well, and see that there could be a reservoir engineering explanation to see that whatever is happening here can be more or less generalized to cover whatever is going on in the other areas.
I would assume, because you're on this, you've taken this rock and you flexed it like that if 679 somewhere right about here, it's just not fractured right here. The whole area is fractured because dolomite is brittle and it's easy to fracture. And the tighter it is, the easier it will fracture. The more porous it is, it'll absorb some of the energy of flexing, but it will fracture. So I would assume you have quite a few fractures throughout EMSU.
Do you know when, like, between which period was there injection in the San Andreas? Do you know when it started?
Injection?
Yeah, water injection in the San
I
Andreas.
do not know. I do not know. I can't answer that.
Okay.
Somebody else would have to answer that for you.
Yeah, so definitely from my point of view, what I want to see is that you do have actual reservoir engineering data.
I've seen this one. No, it's okay.
Well,
Sorry about that. So you do have actual reservoir engineering data, which is going to be the injection rate, the pressures in the San Andreas.
Oh, that I don't know.
Okay.
That I don't know. No, sorry. That's an engineer's.
Yeah. So let me try to make my point.
Yeah.
You do have this actual engineering data, water injection rate, pressure recorded right within the San Andreas. And there has been numerous injection rates over the period. So I want to see that. And then also I want to see within the Greenberg, I want to see the pressure profile. I want to see the production profile. I want to see the water cut profile. When we see this, I mean, most of us, we are all engineers. We should be able to tell, what is the impact of, let's say, if there's a fracture, is it really impacting whatever is going on up there?
Okay.
It's so difficult, let's say, using only one well to generalize within the entire area to say that there could be a vertical migration of the water that is being injected in the San Andreas all the way to the Greenberg, knowing that the first injection, I know Mr. Rankin talked about it. When was it? Can someone remind me? Way back, 1950s. So definitely engineering data, you should have probably, or let's say Empire should use engineering data to back whatever, let's say the one well is saying.
Yeah. And that's an engineering question. I can't answer that. What I can tell you is wherever we have these oriented cores and we do these fracture studies, there's a lot of fractures there. Some are large, some are small, but there's a lot of them. That's the key.
Okay, let's go to exhibit B7. If you can show the core slabs on the screen. B7. Right there.
Yeah.
So are there fractures that is visible here?
There's just a few, but I wouldn't rely on those too much. You can see one there in the middle box at the bottom. You can see one to the side right there. This is in fairly porous rock right here. It would tend not to break as well as if you were slightly tighter. Yeah. Yeah, but that's why I've shown it in that other sample where you can actually see those fractures and solution widened and see how they're oil stained where it tends to be a little tighter. If we could show that one, that would help you out too. Yeah, this right here. Yeah. Yeah. This is kind of, ooh, we got to back off a little. We're a little too, okay, there we go. Because you can, that's a whole foot on the left side. It must have been cut off or something. Okay. Well, anyway, there's about a half foot of section, and there's how many fractures can be there. Now that's non-porous rock. So, well, less porous rock, let's put it this way. And so in that case, this is where you tend to fracture the most. So if you have any low porosity intervals, they're going to preferentially fracture more than porous intervals. Like that last slide we had before this one, you didn't see many fractures. Now here, where it's less porous, you see more fractures. And these fractures, at first glance, they would look like they're not touching each other and they're not connected. Yet the oil stain is telling you the oil has communicated through all of these. So three-dimensionally, all of these fractures are connected. This is what these fracture halos look like. It's a series of fractures, and when they pop, they're all kind of interconnected on the larger scale. And it's really hard to see these in just a little 4-inch core. But here's just a good example of one of these halos. And then this late stage water, this Mother Nature's water flood, has come through and actually solution widened these fractures. So instead of just being little paper thin fractures, they're solution widened. So they have quite a gap to them. And then once the reservoir had a chance to try to resaturate, when that head of energy went away and you could kind of backfill the reservoir, here's the oil coming into these fractures. So that's telling you these fractures are three-dimensionally interconnected.
Thank you. So back to the other one, the B7. So you're showing saturations of oil, 30%, 25%, 38%.
Yes.
Just out of curiosity, let's take one of them. Let's take the first one on your extreme right, upper left.
Okay.
So you have 30% water, 34% water, and then 30 oil.
Yeah.
What is the remaining one? What is the remaining?
This is all they got with the core analysis.
No,
I don't know where the other part went.
No, I'm just saying.
And part of the problem is this has been super flushed when the coring took place. So you have to add extra oil back in, but that still won't get you to 100%. That still won't get you to it. So I don't know where the rest of the numbers went. This is where somebody that has done core analysis for years and years and years needs to come in and explain this phenomenon. But these are the numbers that were generated. The number that I look at, though, is just the SO. I kind of tend not to look at the SW much.
Okay.
Because that's where the money is in the oil. So, and then this is just a conventional core. So in this residual oil zone, this is the lowest saturations. But based on some of the work that was done in Seminole, that tells us, oh, they could be much higher because this has been super flushed.
They could be higher, but at the same time, they could be lower.
Oh, no.
Lower?
No. Because this core has come from 4,000 feet down. That top depth is 4239. And so as you bring it up to the surface and as pressure decreases, more oil will come out. And so as you go down,
I got you.
And that's why they have to take these pressure cores to try to get more accurate readings. But they're really expensive. I've only done one in my whole career, and it was up in North Dakota in the Williston Basin, and it was so hard to just collect about 57 feet of core. It was really difficult, and it was very expensive. So I take my hat off to the people at Hess over at Seminole for even doing a pressure core. because they're time consuming and they're expensive, really expensive.
So, I mean, I'm sure we all agree that in our industry, we don't necessarily just use only one resource to make a determination, right?
Yeah.
So, am I going to see a log that backs this up? Because the log data, unless you have let's say you do have a concern with whatever is coming through the logs, definitely the logs is going to give us something.
Oh, yes.
And then we should be able to correlate that back to the core.
Yes. Yeah.
So irrespective of the method that is being utilized, we still have the core to confirm whatever, let's say, each of the method that we did is going to provide.
And that's a little bit beyond me, but there's a couple of petrophysical guys that will explain that to you.
Okay. I appreciate that. Okay. And I'm really interested in the typical residual saturation for, let's say, a typical reservoir in the EMSU, typical residual oil saturation. So if the engineers are in the room, hopefully they can get me some answers on that.
Okay. Fair enough.
Okay. Okay. You said there will be a log associated with the core information, but is there any FMI?
Pardon?
Is there any FMI data?
Oh, not in these two wells that cored into the San Andres. There isn't. To the best of my knowledge, there is no FMI data on that. That would be helpful. That would be very helpful. Matter of fact, that's an alternative to coming in and doing an oriented core deeper into the San Andres. But then you'd have to orient the core, and so that would chew up some money. And the other is just when you drill down is just to run an FMI and to see the fractures on the image log. That's the other way a fracture study could be done deeper. But the catch is you just see the fractures. You don't get the oil saturation. Okay, so there's this trade-off. What's more important? And to me, I think it's a little bit of both, to see the fractures and to get the oil saturation. That's the bottom line. To know how big this residual oil interval is. You know, what's the resource there? How much is in the San Andres?
So will you say, based on your knowledge in this EMSU, will it be a recommendation to NMOCD that any well that will be drilled through, let's say, this unit where, based on your testimony, there could be some fractures that could impair a producing zone, that there should be FMI run, or there should be a detailed fracture studies performed to establish whether there's going to be any impairment to existing, let's say, production zones?
Yeah, and I'm the consultant. All I can do is say, this would be a good idea. What do you guys think? But they're the ones that have the money and have to shake their head this way instead of no, you know, so I can just advise. But that's a good thought.
So you mapped 313 total fractures, vertical fractures.
Well, in the San Andres, the total fractures were 129.
129.
Yes. Yeah. There's more up in the Grayberg study, and that might be the bigger number that you're thinking about.
Okay.
Yeah. So if you add those two up, that's quite a few fractures. Yeah. So it took us a couple of weeks to do this fracture study because we did it in-house. We did not send it out to Core Lab or anybody else to do it because we wanted to get very familiar with the fractures in the reservoir.
So am I going to see a log where we've mapped these fractures right to depth?
Okay.
Are we going to be able to see, like, is there any exhibit that shows that, or is there going to be as part of the petrophysical analysis where we are coordinating the core as you've shown in some of the petrophysics, and then also showing the actual locations of the fractures for us to more or less see where are the fractures. Are there any top rocks above that, or I mean,
Yeah.
can we see something like that?
Well, the only thing I've done with mine is there's that one illustration of the 679 where we zoom in on the upper San Andres. If we could take a look at that, then I can show you right where they're located, but we really can't see them. But I can show you right where they're located. If could we go to that illustration that shows 679, the core and the fractures? That I don't know what number that is. We just have to move up and down a little bit.
Let's see. No, it should be a log.
Oh, J18.
I don't see a J18.
It's in there. That would be rebuttal testimony.
It would be B. We're thinking B18. That's Hardy.
B18, maybe.
No, B18 is a fracture. Is it? No.
It's the first step of the course demonstrating.
Yeah, but there
This is
should be
B18.
one that shows
The log.
EMSU 679,
Yeah.
the whole core, and then the zoom in on just the San Andres.
So one would be B25. I don't know if that works.
Oh, there we go. Yeah.
Yeah.
Okay,
B25.
there's one other. I think we need to go down one because we've got arrows pointing to the fracture study. Oh no, that's not it. Okay. I don't know.
I see arrows on the B25.
Okay. Okay, if we just, oh, darn it. Where did that go? There's one where we're actually pointing to the top and the bottom of the fracture study. And it looks just like this, but we actually have to the side arrows, but it's on 679. Then you can see that little interval where there's 129 fractures that we measured.
Is it B23?
So he said it's only 679.
J3. I believe it's in the rebuttal testimony. So let me see if I can get that. B23?
There, yes, there. In that little interval, that's the part of the oriented core in 679. That's the base of the oriented core. All the rest of the oriented core is up in the Grayberg. So beneath that lower arrow of those two arrows pointing out where the fracture study was, the rest of that core was not oriented. But this is the base of the oriented core. So we thought, hey, well, let's go in, let's get those fractures. We already had them measured. Let's just make the diagram to show how many fractures are there, how big or how small they are. So that's the interval right there. And
So on this particular figure, Exhibit J3, so what is the red, and then you have the black kind of strings within that? What is that?
These black areas, those are collapsed breccias. These are these little sinkholes that developed with the subaerial exposure of the San Andres. Oh, I'm sorry. I'm sorry. So those and the catch is we don't know how deep the subaerial exposure extended, because if we look at the red line that is the top of the San Andres, that's the unconformity. And when sea level dropped, it probably dropped, let's see, 10, 20, 30, 50, 60, at least about 70 feet to create a series of collapsed breccias. Because one of the problems is with the sinkhole, they're kind of shaped like this, but sometimes they go like they'll go like this down section. And so here we are coring with only 4 inches to look at, and you're in the sinkhole, it's to the side of you and you miss it, then it comes back and you're back in it. So each one of these red intervals could be all tied together. So that would mean that you have at least a 70-foot sinkhole, but vertically as we cored through it, we were in and out of it because it was kind of doing this down section.
Okay.
Yeah.
So based on your knowledge in the EMSU or working in the Permian Basin, is there any reported or published material talking about the potential movement of injected water into the Greenberg from the San Andres?
Other than right here at EMSU, somewhere else, I'm not aware of. I'm not.
Okay.
I can't answer that. I'm sorry.
Okay. Thank you. I think I'm going to pause here so other commissioners can also ask some questions. Thank you.
Mr. Lampkin?
Good afternoon, Dr. Lindsay. Thank you for your testimony. I got a couple of questions for you, probably a little bit more pedestrian than Dr. Ampama's, but try to arouse your interest. So on the fracture halos, on that slide, it indicates that those are generally created as a result of movement of a fault. Are there any known faults in the MSU or the MSUB that you're aware of?
We found one in AGU, and we found a long fracture. I can't remember if it's in MSUB or EMSU, because you're only getting to see this much, 4 inches. So it could be just right there, or it could be over here. So it's really hard to find these faults, and they don't appear to be very big, very small. And you really kind of don't need a fault when you're taking strata like this and you're bending it like that. It's going to break without a fault. I just put one in the middle for kind of convenience sake, because if you do have a little bit of fault movement, then the bigger fractures will be right adjacent to it, and then a little further out, smaller, and then you lose them, making these halos. And so we don't know how big these are. We have no earthly idea. Though when I was in the Middle East, we were actually doing a bunch of laterals through a field, and we went in and out, in and out, in and out of fracture halo. So that's where we kind of learned about these. And so years before, when I was describing the core, I just saw all these fractures, and we just tried to map them as best we could, but we didn't understand there was this potential genetic way of generating a halo here, and maybe a halo over here. And we honestly don't know the distribution of them, how wide or how narrow they are, and if they're all attached to a small fault or not. We just know there's something there where they're three-dimensionally interconnected, because the real surprise was looking at these dinky little fractures that are only this long, and solution widened, and they're all oil stained. And that means the oil had a way to get into all of them. So they have to be three-dimensionally interconnected. So it's kind of like there's a halo of these fractures, not just a fracture. When I was younger, I used to just think it's a fracture. and with a little, with no movement, maybe next to a fault that had a little bit of movement. I didn't realize that if you faulted it or if you just folded it, you could create a halo of fractures instead. But one structural geologist years ago actually published a paper, and I can't remember the name of it, but he actually showed a surface outcrop where he had a photo looking down. You could see the fault and you could see the halo of fractures. And I wished I had a copy of that. This was back in the 1970s into the 80s, that this one guy did this superficial outcrop, and you could actually look down and see this halo of fractures around a fault. But I don't know how big the fault was. I don't know what the movement was on it, but you could see the halo effect. And I just remember it because I thought that was really neat. Well, here we are looking in the subsurface, and we're seeing these dinky little fractures, and all of a sudden their solution widened, meaning fluid got into solution, enhanced them, and then oil was able to migrate back into them and stain them. And how did it get in there? Well, that infers that they're all interconnected. That's the important thing. So there's some kind of fracture halo there, but how big or how small these are, I have no earthly idea.
Okay, thank you. Do you have any insights into the core orientation method that you guys used? Was it paleomagnetic or mechanical?
Paleomagnetic.
Paleomagnetic.
Yes.
You mentioned that the core analysis that you did when you were with Chevron was later revisited by Core Lab. Is that correct? Is that another agency or another organization outside of Chevron?
For doing like the oil saturations and water saturations and porosities and permeabilities.
I'm assuming that's what you're talking about.
Yeah, that's all done by Core Lab. Yeah.
Did you guys do one initially in-house at Chevron?
No, because we had one core facility in Houston, but it's just a very small setup, and they only kind of worked on international projects.
Okay.
So we basically, when the core would come in, we'd call Core Lab, they'd come out, pick it up, take it in, and they're right in Midland. And so it was just a short drive from a couple hours to get there to Midland, and then they would start analyzing the core. So I spent a lot of time over at Core Lab.
Okay. Was the UV imaging, was that technology that wasn't around during the first analysis, or was that performed then?
It was there, but I didn't have any copies of it.
Okay.
And so it's being a retiree from Chevron, it's kind of hard to go back when you don't know anybody there, because it's like a new staff of people, and ask, can I get a copy of the photographs? And there's better technology now with these digital images than the older film cameras. And so the idea was, let's just, if we can get the core from the Bureau of Economic Geology, that's where it was stored, can we get permission to take it back to Core Lab and have them photograph it? And so we did that last year.
Okay.
Once we got permission.
Okay.
And got a nice set of photos. And then they said, well, we can do UV too. And I said, well, these are such old cores, I don't think the UV is going to work. And so they showed me some, and I said, oh, this works great. Let's do both plain light and UV, even though it's an old core from like the EMSU 679 is from 1990. You can still see with UV the oil saturation. That was a real surprise. I thought all the light ends would be gone and we wouldn't get an image worth beans. And they got beautiful images. And these digital cameras, they can see more in lower light settings than the old film cameras can. So it was actually to our advantage to take these pictures with a digital camera versus the old film cameras.
Okay. Another one of the things that you mentioned was how water flooding can change the wettability of a reservoir. Can you expand on your understanding of that or the process by which that would
Oh,
occur?
boy. That's a tough question. I would, how would I say this nicely? If I were trying to explain that, not being a reservoir engineer, I think I'd be prostituting myself. Okay, just to be very blunt, okay? I wouldn't want to try that.
That's
But
fine.
wettability is incredibly important though, because what we found, there was a guy up in Canada at the University of Calgary that did a study on how oil wet and water wet reservoirs flood. And he made little glass models and he he coated one with oil, and the glass was basically acting like it was already water wet. And then he put in real crude from a reservoir and heated it up and had a little entry point and a little exit point, and he put the water through to simulate a water flood, and they flood completely differently. In the water wet case, they flood through the smaller pores. In the oil wet case, they flood through the larger pores. And that was really significant. And so years later, when we were having this this CO2 flood in Goldsmith that didn't work, and we were just sequestering CO2, I said to the guys, hey guys, I think we might have a wettability problem here. If this tends to be oil wet, all the flooding has went through the larger pores, it's displaced the oil, and all we're doing is putting in CO2 into vacated moldy pores. And that's kind of what we were doing. So we proved up what not to do in a CO2 flood in that particular case, because it didn't work.
Okay.
Yeah.
Well, maybe I'll pose that question to a reservoir engineer later. One final question. In the section of the 679 that you guys cored, on the bottom of it where you guys saw evidence of staining that prompted you to think that the saturation went further, did you guys make any estimations on what that saturation was at the low end of the core?
Just what Core Lab was able to tell us. That was all. The thing that caught my eye was the UV fluorescence. That's what caught my eye.
Okay.
And so right then, in one core, it stood out really well, and we saw it right at the base of the core. In the other core, I think it's the 679, it didn't stand out well, but it did in the UV photographs. And so when I saw it in, I think it was the RR Bell, I said, oh, it's got to be deeper. But then the great question was, how deep?
Mm-hmm.
And we don't know. Other than if you talk to some guys that really know how to analyze logs, they can tell you from a log perspective how deep they are. But me being kind of a core guy and working on rocks, I like to see the numbers of the oil saturation myself.
Sure.
But in this case, we have no data once we go past the base of those two cores. And they're just in the upper San Andres. So there's all the rest of the San Andres that needs to be evaluated. And you have to do that with the logs. And that's beyond me.
Okay. Thank you. Those are all my questions.
Mr. Hearing Officer, if I may, I have one or two questions. They're not legal questions, but maybe it's just out of curiosity. But Dr. Lindsay,
Yeah.
I'm asking you just based on your testimony about the communication between the Goat Seep and the San Andres. How large is the Goat Seep aquifer?
Oh, it's not very wide. It's not very wide.
Can you
shoot
maybe acre feet or?
Well, in outcrop where you can see it,
Mm-hmm.
I would guess the width of it would be quarter mile, half mile, something like that, from up dip to down dip, the massive part of it that stands out like a sore thumb. Yeah, it's probably even bigger than that, but that's where I've seen it. On the seismic, you can see a width to it as well. You can see the edge of where here's the Grayberg, here's the eroded interval. It eroded through the Grayberg down into the San Andres actually, and then the Goat Seep is here like this. And that width, I'm not sure how wide it is, but it could be a quarter mile, half mile, maybe a little bit wider, something like that. Not too wide, not too wide that we see on the image on the 3D seismic. Yeah. But it extends all the way around the basin from the Guadalupe Mountains down past EMSU and probably connects with the Glass Mountains some way that's kind of beyond me. Because I have no data.
Do you know if there have been any geologic studies of the size of that aquifer?
No, but there was a PhD on the outcrop Goat Seep by the University of Wisconsin back about somewhere around 1970 or so. I can't.
That's okay.
I can't remember the guy's name. And it was that thick. It was a real well done study.
Let the record reflect that's about 1.5 inches.
A couple inches. Yeah.
Okay.
Yeah, a couple inches.
Okay.
Probably 350 pages. Quite
Okay.
a bit of data. And in an incredibly difficult spot to get to because it's cliffs that are literally that steep. Yeah, so you have to be a mountain goat to do that kind of work. And this guy did it. This guy did it. He was at the University of University of Wisconsin, excuse me. And his professor was known to be a mountain goat. And so these students had to go work with their professor in the sheer cliffs on the western escarpment of the Guadalupe Mountains. And so there were 3 studies done there, 2 master's degrees, and then this PhD on the Goat Seep.
Is it fair to say then that we don't know the size of the Goat Seep aquifer sitting here today?
Yeah,
Okay.
that's a fair question.
Okay.
Because you'd have to get a few wells through it and see how thick it is, how porous it is,
Okay.
and then try to look on the 3D to say, here's the up dip limit, here's the down dip limit, here's my width, here's my thickness, here's my porosity. Then you would know.
Okay.
You'd know. Yeah.
Thank you, doctor. Thank you. Nothing else.
Rosatos, you get a second chance. If any of the commissioners or questions and answers spurred your curiosity.
Yeah, I appreciate it. I don't, thank you, doctor, for your testimony, but I don't have any other questions.
So doctor, is it because of this guy who was a mountain goat that it's called the Goat Seep Aquifer?
No, this guy's name was Lloyd Prey.
Okay.
And he would take field trips out to the Western Escarpment with these students with the University of Wisconsin. And at the end of the day, he'd say, it's time to go stroke the goat. And that meant they were going to have to climb up through these cliffs to touch the Goat Seep. And I felt sorry for those students because it was really steep. But he could do it. He was a very healthy guy.
He was, right, till he
Yeah,
fell.
he's passed away now.
All right, thank you, doctor. So let's see, what time is it? 4:24. I'm hoping we can get poor Dr. Lindsay off the stand today. No pressure.
I have
That's,
very few redirect questions. I think they will be quick because I would actually like to get to Mr. Bailey if we can do that.
It's music to our ears.
Okay, so I will be brief. Dr. Lindsay, when Mr. Rankin was questioning you this morning, he asked questions about a composite sequence boundary. Do you recall those questions?
Yes.
And I just want to be sure it's clear that here, is it your opinion that there is a ROS above and below a composite sequence boundary at the MSU?
Yes, there's one ROZ associated with the Grayberg. And then there's another associated with the San Andres. So there's actually two. Yes, yeah, there's actually two, yeah.
And Dr. Lindsay, did you do a drawing of the
Yes, I
composite
did.
sequence boundary?
Yes, I did.
Okay.
Because I think there was a little bit of confusion about where the composite sequence boundaries are located. And so I just drew a cartoon for you folks. It's basically, here's the top of the San Andres where my thumb is, right there, okay? And here is this is the first interval here is called the Upper San Andres. We used to just call it the San Andres, but then people studying it in outcrop in the Guadalupe Mountains realized there's an Upper San Andres that has a composite sequence boundary on it that the Grayberg rests on. And then there's a Lower San Andres with another composite sequence boundary right here. And then the Lower Grayberg is really thick. It can be a 1,000-foot thick with no problem. And then there's another composite sequence boundary at the base on top of what's called the Glorieta. So those are the big exposure surfaces. And then in the Upper San Andres, you can divide it into an upper half and a lower half. And there in the middle is another smaller unconformity. And then on top of that is what's called the Lovington Sandstone. And then on top of the top of the composite sequence boundary at the top of the Upper San Andres, there's another sandstone that's called the Premier Sandstone. Okay. Now down here, we don't see a sandstone on this composite sequence boundary because this is the bounding surface where the complete Brushy Canyon formation went across this surface and poured into and was deposited in the Delaware Basin. It's a huge volume of sand that went over this one surface right here. So that meant this surface was exposed for a long time, but we don't know how long. We have no earthly idea. We just know that there's a lot of missing time right here where my finger is, right there. And then the next big missing time is up here at the very top. And this is where you start to create sinkholes in the San Andres. And I was showing you in that core description, those red intervals, those were some of the sinkholes. But just to clarify, this is kind of the stratigraphy, kind of what it looks like. There's an Upper San Andres. There's this much thicker Lower San Andres. Composite sequence boundary here, another composite sequence boundary down here, and then one at the base.
And I'd like to offer this as Empire Exhibit J13, which would be Dr. Lindsay's next rebuttal exhibit.
Any objection from Goodnight?
I mean, I don't know what it is. Are you talking about that piece of paper?
Yeah.
I mean, I guess my question is, I don't know if it's different than what any of the other witnesses have testified to.
Is this a brand new exhibit that he did over lunch or something, or what's?
I drew it at lunch, yes.
It is?
It's his drawing to clarify the questions that were asked earlier.
Because there was a little confusion about where are the composite sequence boundaries? And I don't know if I answered it very well. And so I just thought I would just draw a little section to clarify where composite sequence boundaries are, the bigger unconformities, and where they're not. Just to be real simple.
Mr. Hearing Officer.
Mr. Oh, go ahead.
Let's take a 5-minute break. So
Why do we do? Let's give it a 10.
Let's make it a 10-minute break. So it's only fair. This exhibit was a lunchtime exhibit. Let's give people a chance to look it over. So for now, it's not admitted, and we'll wait and see. 10 minutes. Be off the record. Okay, are we back on the record?
We're on the record.
Okay, great. All right, has Goodnight had a chance to look over this exhibit, Mr. Ray?
Thank you, Mr. Hearing Officer. Yes, we reviewed the exhibit and I have no objections to its admission. I've asked council to send me a picture of it and they've done so.
Okay. Pilot and Rice, any objection to this exhibit?
No objection.
None from the OCD.
No objection
from Pilot.
Okay, all right, then it'll be admitted. I don't remember where we were. I'll leave that up to you.
Thank you. And Dr. Lindsay, is it correct that a composite sequence boundary may or may not be a barrier to fluid flow?
Yes, that's true. That's true.
Okay. Mr. Rankin asked you a number of questions about Goodnight's cross-examination exhibit 1, which was the article by Love.
Yes.
Do you recall that? And is it true that the conformance problems discussed in that article were addressing the Grayberg?
Yes, that's correct.
And they were not, the article was not addressing vertical plumes, was it?
That's correct too.
In your opinion, does the article have any bearing on the issues that the commission is evaluating here?
No.
Do you defer to Empire's reservoir engineering and engineering experts on recovery of the residual oil zone in the MSU?
Yes. Yes.
With respect to the core data that you've discussed extensively, the conventional core,
Yes.
it shows a RAWs in the MSU even at those conventional saturations. Is that correct?
That's correct.
Mr. Rankin asked you a number of questions about the depths of the fractures in your fracture study. Do you recall those questions?
Yes.
Okay, and let me try to just share my screen here.
Oh, there we go.
And I've pulled up here Exhibit J12 to your rebuttal. Are those the depths that you were analyzing in your fracture study?
Yes.
And
Yes, we hand wrote them all and put all the orientations in per depth. And then to the right, we put in, are they large or small fractures? Information like that. Yeah.
Thank you. And with respect to the wells that have fractures, and we've talked extensively about 2 of them, but are there 3? Are there actually 3?
With fractures in EMSU?
Yes.
There's just the, well, how would I word that? When I've described fractures, I've seen them in all the cores that I've studied. And they're different sizes, you know, they can be a foot or 2, they can be less than a foot, they can be inches. And even in core where it's not oriented, you see these fractures all the time. And the surprising thing was there's a lot of these little fractures, and they make up a huge number of the total fractures. So there's a lot of fractures in the core. You can't get away from them because of the flexing and making of the anticline. There's just a lot of fracture being.
Dr. Lindsay, Mr. Moander, OCD's counsel, asked you a number of questions about the Capitan Reef and the Safe Drinking Water Act. Do you recall those questions?
Yes.
But you're not a lawyer, are you?
No.
In fact, Mr. Moander had objected to you earlier testifying about a legal opinion.
Yes.
Correct? Okay. And with respect to the fracture studies that Mr. Moander asked you about, and those are the studies in your testimony that we've been discussing here today, is it correct that those deal with vertical flat fractures that allow fluid migration between the San Andreas and the Grayberg?
Yes.
Okay. And so your fracture studies are not, well, let me ask it this way. Do your fracture studies show that there would be any migration to the Capitan Reef?
There's no way that can happen where it's too far away. it's absolutely too far away.
And just to sum up here, and I think this is clear, but I want to make sure. Do you disagree with Goodnight's position that there is no RAWs in the San Andres?
Oh, yes, there's a RAS.
And is that based on your study and characterization of the reservoir, including the core analysis?
Yes,
And do you disagree with Goodnight that there is a barrier to fluid flow between Goodnight's injection zone and the residual oil zone?
yes, because there's too many fractures. And it seems to be, there's discontinuous tight intervals. They don't seem to be continuous.
Those are all of my redirect questions.
Okay, great. Well, then may this witness be excused?
Yes.
Mr. Hearing Officer,
Yes, sir.
based on Ms. Hardy's questions of Dr. Lindsay, I have to ask him a question about the SPE paper that he referred to.
I hate to open the door to
Never ending.
cross-examination, so unless it has to do with something that was brought up on redirect only,
It was redirect only.
and lawyers always say one last question. How many do you have, Mr. Rankin? I guess we can run out the clock. It's 4:43, so
Well,
if you have a few more questions, I don't think, Ms. Hardy, we're going to get to another witness today. That was, in hindsight, very wishful thinking, apparently. All right, Mr. Rankin.
so Dr. Lindsay, I'm showing here on the screen a portion of your transcript from your deposition, okay? And I'm going to show the portion of this discourse between yourself and me, okay? And here, where it says Q, that's me, okay? That's me talking. Where there's an A, that's you. So here I start and I say, the question I have, though, is about back to these wells. You referred to Tracy Love and the work he did showing the high water cut wells. And your opinion that the high water cut is associated only with the water from the San Andres. And you answered, most likely, yes.
Yes.
Question. And that would be from the upper San Andres, right? It would be, yeah. However, water comes out of the San Andres itself, and the upper San Andres is right there at the top. So it's probably coming out of it, and it would be coming out of the lower two. My response, okay. Answer, we just know that it's the San Andres water that's ascending up. And then you said, from plumes of water. My question to you was, your opinion is that San Andres water coming up. No, that's a fact because we analyzed the water and it was sulfate rich. And that's based on Mr. Carpenter's presentation to you, right? And you answered, and basic water chemistry studies done by Hobbs Division in Hobbs, New Mexico before that. So do you have the data on the Hobbs Division water chemistry? You say, no, it was common knowledge though. Okay, so you're telling me it was common knowledge that there were these plumes. You answered, yes. Coming up, yes. But Mr. Love would know that, right? He would be informed of that, right? And you answered, yes. And he wrote an SPE paper on it, so you can look it up. And I said, okay, very good. So now today, Dr. Lindsay, I have presented to you that SPE paper. And if there were such San Andres plumes, which I understood you to say that they were not addressed in the SPE paper. So you're telling me that it's not relevant to the commission's review?
No, it's what Tracy and his co-author were chasing were horizontal high perm streaks that needed conformance work done on them. That was the focus of their work, not vertical plumes.
They're worried about water flood operations and improving the water flood. Why wouldn't they have addressed in their paper an issue that was affecting the water flood if it truly were the case? If it truly were the case that water was pluming up and it was common knowledge, why wouldn't it have been addressed in his paper?
Because they were talking about conformance. They weren't talking about plumes of water.
Very well. No further questions.
And Mr. Hearing Officer, based on a response to a line of questions from Commissioner Ampoma, OCD has a couple of questions they would like to ask on recross that took things a little deeper than they had been on cross-examination.
Well, all right, this is why I try not to open this door, but now I have, and I guess everybody's going to drive right through it. So go ahead.
Thank you. All right, so Dr. Lindsay, I'm going to go back to your deposition in this case during my examination of you. I'm assuming you still recall that.
Yes.
And I asked you a question on where you would place any doubt that you had concerning communication between the EMSU and the Capitan. And I asked if it was, your opinion was within a reasonable degree of scientific probability. Do you recall that?
Yes.
I'm sorry, what was that, Doctor?
Yes.
And do you recall what your response was to that?
No.
Well, you initially asked what I meant by that. And when I posed the query, you said you doubted there was communication, which would bring into question, meaning there's a possibility. You testified there's no communication between the Capitan and the EMSU. Do you recall that?
Yes.
And then you stated further, if you wanted a little more rock solid, there's no communication.
Yes, that's correct.
Thank you, Doctor.
That's because they're
Well, that's all right,
two
Doctor.
townships
Thank you.
apart.
Thank you.
That's why. It's too far apart.
I'm going to ask that the continuous answer be stricken. Dr. Lindsay's got a habit of continuing to answer questions after the answer's been provided.
I'm not going to strike it. I think it's probably the third time we've heard it, but he's been consistent in this testimony throughout. You asked a question. Yes, does he over volunteer? That's why you've been here all day. Lindsay. But, you know, it is what it is. This is going to be a long hearing and all the stuff is interesting. So I, for one, thank you for your time. You have 12 minutes to put on another witness or we can close for the day. Ms. Hardy.
Yeah, let's just start fresh tomorrow at this point.
I think that's a great idea.
Thank you.
And as a housekeeping question, I assume we're going to lock the hearing room, so perhaps binders could be.
Binders. So before we start with your housekeeping, Mr. Moander, I think Commissioner Ampoma had a question regarding the case itself.
Yeah, would like to know the order of witnesses, and I think Mr. Rankin would like, needs that courtesy as well.
Sure, and I gave it to Mr. Rankin earlier, and I can give it to you as well. Our next witness is Ryan Bailey.
And then after that, is it Mr. Burkhead?
Yes.
It may be overly optimistic, but if we get through more than two witnesses tomorrow, who's going to be the third?
Dr. Jim Buckwalter.
Anything else, Mr. Rosado?
Not, I don't have anything else for the case unless anybody else on the commission does.
May I just pipe up on the order of witnesses? My understanding is that the only, that Empire only has one witness who has a limitation on availability. And that was Dr. Trentham, is that correct?
I believe at this point that that's correct. Dr. Trentham needs to testify on Thursday.
Okay, and then after Mr. West, we had discussed what the other sequence would be. Is that going to change, do you think, between now and the time that they're presented?
I don't think so.
Okay.
We might have to make minor adjustments, but
Okay. And that would be Melzer, Dillowin, McShane, Wheeler, and then Trentham, and then Merrick. Is that right?
yes.
Okay.
I will just state, everybody start looking at your calendars because we're not going to get through all of these people by Friday. And the scheduling is getting tight. So make sure we as the commissioner are looking at calendars. And I think everybody in the audience also needs to start looking at calendars because we're going to have to start proposing dates by Friday. So just keep that in the back of your minds, please.
Thank you.
Mr. Hearing Officer, if we're done with the actual case part, we do have the housekeeping question that came up.
Okay, we probably don't need to have that on the record.
No.
So we can release the long-suffering court reporter with our thanks for today. And we'll reconvene the hearing again tomorrow morning promptly at 9 o'clock.
And Doctor, thank you also for your patience as well. So going back to your question, Mr. Moander, the hearing room will be closed. Cleaning staff does have access to it through this door in the building, but they are badged to be able to come through this hallway. So the room should be fairly secure. Thank you all.
Thank you, Mr.
Have a good
Chair.
evening. Be safe. We'll see you tomorrow at 9.